Just like that.
Recording in progress.
You guys are totally on the ball because I totally would have forgotten. Okay. Why should wiring between the power source and radio be heavy gauge wire and kept as short as possible? This is the same reason that power companies don't like using low voltage, to keep your voltage from getting too low at the radio. If you have really thin wire, you lose a lot of voltage in the wire itself, and all of a sudden you find that your 12-volt battery, when it gets to the radio, is only at 8 volts, and the radio stops working when you transmit. So that's the same reason we try not, if we're using a lot of current, we don't use the cigarette lighter plug. How can a computer be used as part of a as an amateur radio station? For logging contacts. Just for fun last night, I did some of that. There was a contest going on that I participated in, and my log looked just like this. So this was 1 hour of operation, and I used my computer to do the logging. It's also used for sending and receiving Morse code, and for generating and decoding of digital signals. Modulation and demodulation is MO, modulation, and demodulation, DEM. If anyone's ever heard of a modem, your computer works very well as a modem. What computer sound card port is connected to a transceiver's headphone or speaker output? Okay, so the easiest way to describe all this is just to draw it. So every radio is going to have a microphone input, and every radio is going to have a speaker output. Now, the radio is also going to have this thing called a push-to-talk line, which is literally just push-to-talk. So the computer that you connect to it is going to have a microphone input. The speaker of the one goes to the mic of the other, and it's going to have a speaker output that connects to the microphone of the other one. And then there's some output that's going to connect to the push-to-talk line. So when this output turns on, the radio switches from receive to transmit. Push-to-talk is PTT, which literally means push to talk. On a handheld radio, this is the button on the side that lets you talk. It switches the radio from receive to transmit. A sound card. What's the use of a sound card? Well, a computer has a built-in sound card, for instance, that allows you to convert your microphone, like what I'm talking, into a signal that the radio can do something with, and vice versa. Okay, we discussed this yesterday. If you have distortion on a signal, you can take a microphone cable and wrap it around a ferrite choke. We talked about that yesterday. A ferrite choke is basically a piece of ferromagnetic material, which is basically iron powder baked with glue in the shape of a donut. You wrap your cable around it, and it absorbs the magnetic fields and keeps cables from coupling with each other. And it basically, if there's radio frequency energy coming down into your computer or into your radio from your antenna, because it's sitting in an electromagnetic field, it'll choke it out, and you won't get it into the microphone input. Again, that's the reason I have 5 chokes on a single cable, because 4 wasn't enough. Which of the following conductors provides the lowest impedance to RF signals? Again, everybody, what does RF stand for? Radio frequency. Okay. So AC versus DC. If we look at the cross section of a wire, DC will have current that's uniformly distributed throughout the wire. AC, on the other hand, likes to flow on the outside of the wire. And that's due to something called the skin effect. So since it likes to flow on the outside, we're basically just looking at this as the surface area. So if I have the same amount of copper, and I can take a piece of wire and make it in the shape like this, or I can take it and flatten it out and make it like this, which one works better? Which one has more surface area?
The flat one?
The flat one. So the flat strap of cable has a much lower resistance or much lower impedance to RF energy, to AC. And that's why most of our grounding, we use flat strap instead of round copper wire. If you're going to be connecting something to a car battery, you typically will connect it directly to the battery. The negative terminal will go to the engine block. The reason being that we don't have to go through the cigarette lighter. We don't have to try to use the car's frame as ground. It doesn't really work all that well. And sometimes the ground that you get in the frame of a car is not really a very good ground. And everybody, what is ground another word for?
Earth.
What is it?
The earth, the ground, the dirt.
Yeah, what is electrical ground?
It's neutral. It's 0.
It's 0 volts. That's our reference point. It's called our 0 volt reference. Okay, so let me ask a question. Let us say that we have a station on the second floor of a house, and we go through the house wiring, and we find the negative. We find the ground terminal on our electrical outlet, and this is connected to ground, obviously a water pipe or something like that. So, okay, so we have this long wire. Well, this is what we call safety ground, because this might be, let's say, 80 feet long. What is the wavelength of of 60 hertz? Right? Now, that actually is 60 hertz. It's like a fraction of a megahertz. That's actually 5 million meters long. Or from New York to California. That is one wavelength at AC power. So, compared to that, how long is this 80 feet? Compared to New York to California, how long is 80 feet?
A drop in the bucket.
A drop in the bucket. So ground is really ground. Okay, but now, let us say that we're on a radio frequency band. 80, and we're still at 80 feet, but the frequency that we're on is the 10 meter band, which has a wavelength of 10 meters, which is about 33 feet. So what we're going to do now is get rid of that, and we're going to draw waves, and we know that we're going to have a bunch of waves. Ideally, this is at 0 volts, so we're going to say that this is at 0 volts, and we're going to start drawing waves. We go up, and we go down on this curvy wire, and we go up, and we go down, and we go up again. Well, what do we find? We have a 0 volts right here, and a 0 volts here, and a 0 volts here, and a 0 volts here, and here. But what do we have here? Is there any guarantee that that's 0 volts?
No.
There's not. And in fact, depending on the band that you're on, the frequency that you're using, that actually can change, which basically means you lean in to touch your microphone, and what happens? This is suddenly at 100 volts.
Get zapped.
And I have had that happen, where I leaned forward into the microphone and got a zap on my lip as soon as I started transmitting. And that's because safety ground is not equal to RF ground. They are different things. And this is a very important distinction. That is why it's important, if you have a grounded station, to try to get the station as close to earth ground as possible, so that you keep that wire as short as possible.
So you would do a dedicated run.
You would do a dedicated run and make it as short as possible.
So what did you say the safety ground was not equal to what? What did you call it?
Safety ground is not equal to RF ground.
Okay.
Because RF has a short wavelength compared to power. Okay, the source of a high-pitched whine that varies with engine speed in a car is called the alternator. Which of the following could be used to remove power line noise on ignition noise? That's something called a noise blanker. Now, the reason that works is that ignition noise looks like little lightning bolts. And lightning makes these little pulses that goes like this. Pop, pop, pop. And at a certain speed, they're periodic. They have a certain, you know, at certain RPM of your car, they go pop, 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 whenever there's a spark plug that fires. Your radio basically says, okay, well, I turned on the noise blanker. I know that there's a periodic noise. Oh, there's the period. It's between there and there. So what happens is your radio, during that period, takes the gain of the radio, gain of the receiver, and drops it really, really low. Effectively saying, okay, well, you're not going to get any you're not going to get any signal there, but you're also not going to get any noise. So what you're going to have to do is you're going to have these little blank spots. If you're listening to somebody's voice, it's not really a big deal. But certain other modes, it may very much matter if the signal goes away during that time. So, and that's called a noise blanker. So, what to the following would reduce ignition interference to a receiver? That would be the noise blanker. Okay, the next one we're talking about
Hey,
is
Scott.
filtering. Yes.
Good question. Where in the sequence, where does the noise blanker actually fit?
It usually is in the IF chain, so it's in the intermediate frequency chain of the radio. So the noise blanker, I mean, you can do audio frequency noise blanking, but by that time your receiver gain is greatly affected. So really what you would typically do is you have your antenna here, and you have an amplifier coming down. Then this mixes through a mixer in something called a local oscillator, and it combines two frequencies and puts out an output. And then this goes through a filter, and then this goes through an amplifier, and then this goes into another mixer, or this could be the product detector, right? So this could be a local oscillator mixer or a product detector, and then eventually this comes out to your speaker. So the noise blanking can be done right here, you know, or it could be done right here. The earlier you kill it, the better off you are. So if it's done in the IF chain, as it's called, or intermediate frequency, it saves your ability to do more filtering in the audio section. So this would be the audio portion.
Why couldn't you put it in the antenna?
You could, except that usually these signals are going to be really, really weak coming into the antenna. I mean, it's typically going to be radiated RF noise. So, I mean, you're still going to, basically, you could put it right here after an amplifier. Except that part of the problem is, you know, that you're going to be listening to a whole bunch of different frequencies. But yeah, you could do it. Anywhere that it'll fit. Usually it's done in the IF. Because that's just a certain set of frequencies, and you're already doing filtering anyway.
Scott, I had to join late, so I know you've already said the page number, but could you repeat it?
58.
58, 58?
58.
Thank you.
Okay, so now what we're going to do is we're going to do I guess I'd call it a practicum. Can everybody hear this? Do you have audio?
Yes.
Okay, here we go. Notice I have a filter that says we're at 0.4 kilohertz. I can make this wider. Notice what happens. I can make it narrower if I just want to hear. And what happens if it gets really narrow? It starts to sound hollow. Now, this is actually a perfectly set width to listen to, let's say, Morse code. I can also change the high end. I can shift the whole thing to a higher frequency. I can shift the whole thing to a lower frequency until it's completely inaudible. So basically what we're seeing right here is a pictorial view of a filter. There's the high cut, there's the low cut, and I can make it so that I can shift the entire pass band to a different frequency. Let's say I want to listen to a high pitch. Okay, now I can also change the bandwidth. Notice it stretches the whole thing out. I can make it really wide. I can also switch from watching what's happening, lower sideband to upper sideband. Notice that the filter did what? Lower, upper, lower, upper. What did you notice just happened when I did that?
Went from one side of the carrier to the other.
Yep, it went one side of the carrier to the other. And let's pick a single sideband signal. Okay, so we are clearly listening to upper sideband. I can actually make this wider. Does that do me any good? Not really. All the information you can see is within that little stripe. Now, if I listen on the wrong sideband, listen what happens. I'm putting it back together wrong. That's how you know you're listening on the wrong sideband.
But I don't know why you're calling me.
I can also listen on AM. But notice what happens on AM. It sounds all distorted, right? The reason it sounds all distorted is that AM, if we're on upper or lower sideband, we're re-injecting energy of our own reference carrier frequency. If we're on AM, we're expecting it to be there, and because it's not there, it sounds all distorted. So, why would we do something like that? Let's say that this is wide enough to listen to. How about this over here? There's no signal there right now, is there? But what if there was another signal there and we decided we're going to widen this out? Then we would be getting distortion because we'd be hearing both. That's right. There's no reason to hear both. So what we have right here, this is known as selectivity. The fact that we're able to select what we're listening to. The same way that I could come down over here. We're listening to a digital mode right here. This is another digital mode right here. The aliens are coming. Now I could also filter so that I'm just picking up one particular signal out of all of those. That's known as selectivity. Sensitivity is the ability to hear something at all. That's there. Notice this here, right here says dBm peak. This is actually telling me how strong the signal is that's coming into the antenna. Sensitivity is the ability to get weaker and weaker signals coming in and still be able to hear them.
So you're listening live right now.
This is live. This is actually live.
And who feeds this? Who feeds that?
This is actually this is actually coming out of the Netherlands, but these are all web-based, software-defined radios. You go to
So someone has a receiver and connects it to a computer?
Yep.
Okay.
Or in some cases, the computer is just just like a sitting on top of. It's like a little Linux box, a BeagleBone, or like a Raspberry Pi that is listening to it. Software-defined radio, yeah. And it's these are all software-defined radios. And the website is called WebSDR, and this is open to everybody everywhere, anywhere in the world. The one we were listening to is out of the Netherlands. It just happens to be one of my favorite ones, and it's at the top of the list. It's everybody's favorite. So,
but you can't transmit.
No,
you can just listen.
You can just listen, but you can actually, if you are transmitting and it can hear you, you can actually hear yourself, which is kind of cool.
Scott, your voice is quite a bit softer than it had. Maybe you're just, but it would help if your voice was a little louder, or maybe the original sound thing or whatever.
You're muted right now, Scott.
There we go. How about now? Is that better?
Some better.
Let me test my microphone. Hello, hello. Okay, well, that's what I get. It sounds.
You're
it
coming
sounds-
across fine.
Okay, it sounds right now. So, okay, here we go. Operating controls, tuning, filters, squelch, etc., etc., etc. Okay, first, what happens if?
Sorry, can I ask you a quick question before we go on? Sorry.
Sure.
So I was reading well, one of the questions is that you have to speak the English language. Do you know
No,
if that?
You don't.
Oh, okay. Okay,
You
so we
have
can
to identify in English.
okay. So I can identify in English and then like I can speak in Cherokee, for example.
Sí, absolutamente. Hablamos en español aquí. De
Okay,
tiempo a
all right. I
tiempo.
was just making sure because a lot of our elders speak in Cherokee and
Yep.
we could speak together.
That's
Okay,
fine.
thank you.
That's fine. You just have to, like, for instance, when I operated in Chile, I could speak in English on the air, but I had to identify as Charlie Echo 5 Diagonal Noviembre 7 J India.
Okay, that makes
Because
sense.
whatever the local regulations are regarding identification, you can speak the language, whatever language you want when you're talking. It's very interesting to hear somebody in Southern California having a conversation in Tagalog or Swedish with their friends back home.
And now, do you need to be licensed in the state that you're the country that you're operating in?
Yep.
Okay. So
And-
to operate in Chile, you had to
I had
license
to
in Chile.
get, I got a reciprocal operating permit.
okay.
Chilean government gave me, I applied for and got a reciprocal permit based on my U.S. license.
That's one of the reasons why I'm here now.
Yeah, exactly.
On
Like,
one of my practice tests, there was a question about when you could use kind of coded language or something like that.
only
About
when you're not allowed to obscure a meaning.
yeah, but what is that about?
There are other services for doing that. You're not allowed to obscure a meaning. Period. Unless you're sending codes to a satellite or a remote control craft, because they don't want somebody else taking over your craft and crashing it into the ground. But that's it. If you want to obscure a meaning of something, you can pick up your cell phone and make a call. That's the rule.
And basically, it's because you're on public airwaves or something.
Well, that's the nature of amateur radio. Period. You're not allowed to obscure a meaning. What can happen if a transmitter is operated with the microphone gain set too high? Basically, it sounds like this. You start screaming into the microphone, and you exceed the ability of the amplifier to be linear anymore, and then you do something called flat topping, and you sound all distorted. What can be used to enter the operating frequency on a modern transceiver? Notice this thing has a keypad. I've also got a tuning knob. So the keypad is the keypad, direct entry of a frequency, and the tuning knob, this ties into something called a variable frequency oscillator, or VFO. This knob up here is my VFO knob. Allows me to change the frequency. Most modern radios also have memories, the ability to store memories. This, for instance, can store 1,000 different channels in memory. You can scan through them one at a time. You can scan through just a small number of them. Virtually every radio today has memories. What's the purpose of squelch on a transceiver? This is very easy to demonstrate. Does everyone like listening to that? How about if I do this? That's much better. Basically, the squelch allows you to basically mute the receiver's output when there's no signal to listen to. Repeater offset. This is the same thing. This is very similar to operating split. So a repeater station will be listening on a given frequency and transmitting on a given frequency. So the input to a repeater is one frequency, let's say 146.12, and the output is 146.72. The difference between the transmit and the receive frequency is known as the offset. On the 2-meter band, the offset is usually plus or minus 0.6 megahertz. Or, if we write it the other way, plus or minus 600 kilohertz. That's on the 2-meter band. On the 70 centimeter band, it's plus or minus 5 megahertz, usually. Those are standard. And this difference between here and here is known as the offset. And depending on the frequency that you're on, that will determine whether or not it's plus or minus. The published frequency of a repeater is its transmitting frequency. So this is the frequency that you will listen to that's going to be published in all the books to say that I want to listen to W7PXL in Eugene, Oregon. It will be on that particular frequency. Now,
but the person who is sending is sending at the other frequency.
Yep. And in fact, when you grab your radio, if you transmit, you will be switching frequency automatically based on the fact that you've programmed your offset correctly.
Okay.
Another thing that you have to program.
Duplex. Saying that's called duplex.
Duplex. Another thing that you have to do is you have to set something called a Ctcss or PL. And that's in, for instance, 100.0 hertz. This is a subtone that we kind of discussed yesterday, also known as private line, with the Motorola trademark. This basically says that the repeater, unless it hears this low-pitched tone, will not open its squelch to you and retransmit your signal. So in the book, what you'll find is that you'll see a repeater that's listed as 146.72, negative 600 kilohertz offset with a Ctcss of 100.0. Sometimes this might actually be listed as D023. This is known as digital coded squelch. And basically it's a little bit of a programmed frequency hopping thing. And if it says I'm listening for a DCS tone, and you don't have it programmed in, you won't be able to use the repeater. The same thing with the PL. Okay. Next, something called receiver incremental tuning. So, we just talked about split or offset. Repeater incremental tuning is where you have your repeater or your receiver right here, and let's say that your transmitter is really part of the same radio, but it's a little bit separate. You can control it separately. Your transmitted frequency is on 14.306 megahertz. Your received frequency, ideally, is 14.306 megahertz. But you find that the other station is a little bit off frequency and is actually transmitting on 14.305, which means that you really want to retune your receiver so that you hear the other station properly. But the problem is, if these are linked together, what will happen is, as soon as you do that, this frequency will change, and then you will be off frequency, and the other station will not be able to hear you correctly. And what you end up doing is moving both of you up or down the band. So, in order to do that, what we do is we have something called RIT, which is receiver incremental tuning. This is also known as a clarifier, which allows you to change the receiver frequency without changing the transmit frequency. Now, a lot of radios, just to do it, also have XIT, which is transmitter incremental tuning, which allows you to change the transmitter frequency a little bit. And once you're doing that, that's known as operating split, because you have two different frequencies. Okay. The purpose of an automatic gain control, or AGC, that basically there is the let's say that you're listening to somebody and they're really quiet, like they're talking really quietly, and you have your headphones turned up really loud, and then somebody comes on frequency yelling really loud, but you already had your headphones cranked up super high to hear the really quiet station. Right? What will happen to your ears?
Pardon?
You might go a little bit deaf temporarily,
What?
right?
What?
Yeah, exactly. Well, okay, AGC, what the function of automatic gain control is that it automatically, whenever there's a really loud signal, reduces the gain of the receiver so that you don't go deaf in your headphones. If you have a radio, like an old-timey radio that didn't have AGC and you've experienced this, it can be quite painful. So that's AGC. The purpose of having multiple receive bandwidth choices on a multi-mode transceiver is that it permits noise or interference by selecting a bandwidth matching the mode, which we just experienced using the web SDR. For single sideband, the proper setting is about 2.4 kilohertz or 2400 hertz. For Morse code, a good setting is about 500 hertz because it's a much narrower bandwidth. Now, obviously, you can go wider or narrower, but the narrower you go, the more it sounds like you're listening inside a tunnel. So 500 hertz for Morse code is a nice, comfortable setting. Push to talk is PTT. Again, you have a push to talk button right here on the side of the radio that switches it from receive to transmit. Okay, now we're talking about station equipment. A transceiver is a...
Wait a minute, just real quickly. All these controls and things are not available on all radios, right?
You will find very few of them on a handheld radio.
Yeah, but they're just bells and whistles and more things available.
Well, there's no point to having them on an FM radio.
Uh-huh.
There's really not, because FM is pretty set in stone.
So, okay.
So for instance, like you don't have a microphone gain on this. This is your microphone gain.
Mm-hmm.
That's your microphone gain. You move it closer and further away to your mouth. If somebody tells you your gain, your voice is really low, then you go like this. And if they say your voice is still low, then you start screaming. If you're like this and they say, hey, you're flat topping, you're distorting, then you basically talk quieter or pull it away. That's your microphone gain. This is a transceiver. It's a portmanteau of the words transmitter and receiver. This is a transmitter and receiver built into one box. A transverter is a mixture of the words transmitter and converter. So let's say that I have my transmitter right here, and it's feeding into this device. Does anyone remember what that thing is called?
It's a mixer?
That is a mixer. Okay. So let's say that this is operating on 28 megahertz, and this is at 194 megahertz. And a mixer combines two different frequencies to make a new frequency, or actually a whole bunch of other frequencies. Well, add them together, and I get 222. Right? But I also can subtract them and get 166, and there's a whole bunch of other stuff. Well, a transverter allows me to take the signal off of one band, this is the 10 meter band, mix it with a different frequency that I've created by using something called an oscillator, and generate a brand new frequency in a different place. And in this case, the 222 megahertz band, also known as 1.25 meters. Now, similarly, if I reverse this path and I have a signal that goes this way and I mix it with that same frequency, I will get 28 megahertz out. Now, I'm also going to add some filtering here and filtering here, so I can just listen to what I want to listen to. But basically this is a block diagram of something called a transverter. It's essentially a mixer in a box with a given reference frequency that it's mixing the frequency with. And I can actually make this into a transmitter and receiver. And this is known as a transverter.
And why would you use one of these?
One of the reasons that you would use one of these is because there is not a lot of equipment out there for 1.25 meters. It's not a commonly used band. Another one is 33 centimeters. That band, which is 902 to 908 megahertz, there's not a whole lot of, or 902 to 928, there's not a lot of ham gear that's ever been built for that band. But there's a lot of space up there and a lot of bandwidth that we can use. So if we were to take, let's say, a 2-meter radio at 144 to 148 megahertz, take those frequencies and mix it with something to make, let's say, 902 to 906, because this is only 4 megahertz wide. So we could basically mix that with something, and it would be 758. So we would have a local oscillator at 758 megahertz. We would then run that through our mixer and generate that range of frequencies.
Is that because might be less traffic?
There's
Is
less
that why
traffic,
you want to do that?
and it's a different band. It's a different thing to try. So you can build your own transverter if you have a mixer that is capable of operating at those frequencies. And then you'd basically run that through a power amplifier and then put that out through your antenna. And you're now on a new band. And let's see, here we go. What device increases the low power output from a handheld transceiver? That would be called an RF power amplifier. We just talked about that. What is the function of the single sideband CW FM switch on a VHF power amp? Okay, so, and I know Kent just showed up. Kent, I'm just going to draw this real quick, and then I'm going to give it to you. Okay, so let us say that this is our transistor. Remember, a transistor operates like this. So we have this linear region right in the middle. We'll call that the linear region. And we have saturation and cutoff. Well, AM modes require linearity in order to be able to reproduce things that are nice and clean. An FM amplifier does not really matter. An FM amplifier doesn't really care, because what's going to happen is all we're really interested in is the frequency. We go faster and slower, and we change our frequency, and then we amplify it, and then somebody cuts off the top and the bottom anyway. So it doesn't matter if it makes more or less signal. What's really important is the frequency that's contained inside. So there's a switch that says, okay, well, we're going to operate in FM or in AM. If we're operating in AM, the amplifier is limited to operating in that range. So that would be for single sideband or CW or AM. If we're in FM, we basically allow it to operate in the entire range, because it doesn't really matter. It's going to be cleaned up at the other end. And so that's actually a more efficient mode of operation of the amplifier. We talked about sensitivity. If anybody can hear what I'm saying, that means that your ears are very sensitive. So that's sensitivity. Selectivity is, okay, on the count of 3, what I want everybody to do is unmute themselves. So go ahead and unmute yourself. Ready? On the count of 3, say your name. 1, 2, 3.
Yeah.
Okay. If I could pick one of you guys out, that would be selectivity. I can select one from everybody. An RF preamplifier would be something that you install up at the antenna. Essentially, what you can't what doesn't exist, even if you try to amplify it, all you'll be amplifying is noise. So what you try to do, this is actually very common for moon bounce stations and things like that. You put a preamplifier outside, very close to the antenna, so that if there is something coming down but it's really weak, you amplify it right here so that it's a little bit stronger. So even if it makes it all the way down to your receiver, when it makes it down to your receiver, if this was super weak, if you had your amplifier way down here instead, you'd already have lost your signal and you'd just be making noise louder. So that's why you want to put your RF preamplifier up as close to the antenna as you can.
Pending serviceability and everything
Yes,
of that
and in
nature.
fact then, because it's outside, it needs to be waterproof and you need to get power to it. There's all kinds of, all kinds of considerations. Which of the following is used to convert a radio signal from one frequency to another? Everybody?
Transverter.
Yeah, a transverter. And what's inside a transverter?
A transistor and a converter.
Nope.
Oscillator and a mixer. Starts with an M, ends in an R.
Yep. That's
Mixer.
a mixer. Yep. A local oscillator and a mixer. Okay. And the process of combining speech with an RF carrier signal is known as modulation. And when you take it out, that is known as demodulation. And if you combine those two things together, you get a new word again, which is modulation and demodulation, which is a
modem.
Modem. There you go. Okay. All right. So we're now on to page 62. And with that, Kent, take it over.
Morning, everybody. Learning a lot from Scott.
Morning.
I hope so. I'm Kent Petty. I'm the chairman of the Anchorage Amateur Radio Club, VEC. We're the first VEC in the country. A VEC is a volunteer examiner coordinator. A VEC is an entity. It's not a person. The person that helps administer examinations is called a volunteer examiner. So VECs coordinate the examinations and the examiners. Anyway, as I understand, many of you are going to be testing with us here on Friday afternoon, tomorrow afternoon. Is that right? Yeah, very good. What'll happen is we're going to have a block of time. When it comes to exam time, we're going to give you a call. So need you to be available. We're going to give you a call. We're going to try to get you all run through. I'm not sure how many people we have registered right now.
I think we have 10 right now.
10 registered. So we'll have a team of examiners, and you'll join the session on Zoom, as you are all very capable of doing. The thing about this testing session is that we need a second device in. So most people, you simply use their telephone, their cell phone. We won't, when you join on that second device, you'll say no to the audio question. We don't want two audio feeds because it'll be bad for everybody. It'll be very painful in our ears.
It's called oscillation.
A lot of feedback, right? But we've done thousands of these. We're very good at it, and we'll help you get through it. So anyway, you'll join the session. We'll get both devices in, and then we'll push you off into a breakout room with your team of examiners, and they'll get you prepped up, and they'll give you your exam. Couple things tomorrow. You won't be able to use headsets. No smartwatches. Let's see.
No programmable calculators.
No. Well, you could use a programmable, but we just show that they're cleared. Yeah.
You can't use your iPhone as a calculator.
Yeah, just a simple 4-function calculator is really the best if you need it. You can have a blank sheet of paper. Try to prepare your test area. I want you to pretend that you're the remote examiner and you have to administer an examination to someone, and you're worried about stuff being there, right? So you want to have sort of a sanitize your testing area. And so when you get in there and set up, the volunteer examiners are going to ask you to take your second device, probably your cell phone, and we're going to take a look at the entire room. We're going to have you swing it around the room. They'll take a look at that. They'll have you swing it up to the ceiling above you. They'll have you show down on the floor by your feet. They'll have you we'll take a good look at your desk and testing area, and then we'll get that camera set in a proper way. And we want to be able to see the computer screen that you're taking your exam on, and your hands and your keyboard, and your desktop. It's sort of a over the shoulder kind of look from the side, if you understand. Your primary device, your primary camera that you're on your device you're taking your exam on is going to be just like this. We're going to be looking at your face. So during the exam, we want you to focus on the computer. Don't be looking around the room and all of this kind of stuff, okay? You want to let everybody, if anybody else is in your testing area, you want to keep them out of the room during the exam. You need to be by yourself. And I think those are pretty much the highlights of this whole thing.
Does anyone need, if anyone needs to go early, that's a good thing to know.
Yeah.
Because we do have some East Coasters. So
Yeah, if anybody needs a certain time or needs to get done early, just let us know, and we'll get you going there.
So I have a question.
Mhm.
It mentioned that we need to be available for a window of time. Is this like we're talking about a few minutes, or I could get tested like 3:30?
Well, okay, so we're going to assemble a team of volunteer examiners. So we're going to have probably 12 to 15 examiners. It takes 3 examiners to administer the exam. And I've got 10 people, so we're going to work 3. It takes about 20 to 30 minutes for a typical exam. So that's what we're looking at here. It depends on where you're at in the stack, if you will, but we get you through as fast as we can. We don't want you all to join the session at the same time and you could all join at the same time and then you just be waiting for your slot. So we're just saying, hey, go on, just be available. We'll give you a call when it's time to do the exam. Okay.
And why not do this as an open book? I mean,
because the FCC says we can't.
That's crazy. I think that's crazy. Anything you need to know, you can research and look up in operation. So.
Thou doth protest.
Well, yeah, but you got to know some rules, and whatnot. So there are some minimum things that it's just a different radio service. It's not CB, it's not GMRS, it's not an unlicensed service. It's a way more disciplined sort of activity, and there's a little higher level of professionalism and that
Jill,
sort of thing.
It used to be that you used to walk into the exam and they wouldn't give you any. You'd have no notice of what was coming.
Yeah.
So
I know, but I just feel like it's such overkill for our purposes.
Define our purposes. There you go.
I need a handheld radio so I can communicate and ask for help in the woods where cell phones don't work.
Yep.
That's it.
Yep.
0.
Well, there are other people ask this question. Well, they want to get an FRS radio or they want to do GMRS, and you could do those things, and those can be the right answer for certain things. But the challenges are that oftentimes there's not as much power available on those other services and whatnot. You have to remember, you've got one of the reasons that there are more stringent rules with amateur radio is because you have the capability of actually really hurting someone with the power levels we're talking about, especially at microwave frequencies. If you fire up a transmitter at 3.4 gigahertz with 30 dB of gain and you point it at somebody, you will kill them. So that's why this is a licensed service. You have to kind of know what you're doing. We're going to let you play with really cool toys, but you got to know your stuff. So
that's the exact same example I used yesterday.
Yeah, along with the notion of being able to have a radio that you're in the woods with that you could talk to somebody. Remember, unlike FRS and other radio services, we've got repeaters and all of these sorts of things that could really extend your range that you might not have available in other services. So it's a really capable service. You can even talk to satellites with that handheld, if you know the satellite schedule. Yeah. So if you're really remote, there's a lot of things you can do.
Yeah. But for what purpose? Why would you ever talk to a satellite?
Because it's there.
Because
we launch our own satellites, Jill.
Yeah, because I'm in Alaska and I'm out on a hunting expedition or I'm wherever, and we have an emergency and something going on, and I know I've prepared myself. I've got the satellite pass schedules, and I need to just check in, or I've got an emergency, so I know I get this information out.
Okay.
Okay. I have a different if I can. I have a different sort of problem in that my cell phone is one of these.
Can you borrow Lisa's?
Not actually going to work too well for having a second camera available.
Chuck, can you borrow Lisa's?
Lisa is away on a trip right
that's
now.
right.
Yeah, so
Okay.
I would have to, I guess, schedule a different time when I could borrow it or something. So I'll talk to you separately on that. Okay.
Well, can I just, I get this, we get this sort of thing lots. Chuck, do you have any other devices? Do you have tablets, an iPad?
Oh, I have an iPad.
There you go.
Your iPad will work as your second camera.
Okay, there we go. All right. Hopefully I'll be able to get it done. Yes,
Yeah.
Thanks for thinking about that.
So the other thing is when you're in, once we get you all set up, we're going to have you bring up your favorite browser. We're going to ask you to close all the other programs on your computer. You're going to bring up your web browser, and we're going to steer you to a website, which is our examination platform, and we'll give you your login credentials, and we'll get you up and running. So you'll need to make sure you've got your U.S. government issued photo ID, because we're going to ask to see that. The volunteer examiners need to say, yeah, this is really Marcia Galvin. Yeah, that looks like Marcia. Yeah, okay, that's good. All right.
So a question about where you have to position the cell phone. Is that you keep that cell phone positioned throughout the exam?
That's right.
But if there's nothing behind you to put it on, do you need to find something to put it on, or how do you position it correctly so that it meets your requirements?
A table, a chair, a cardboard box.
People use duct tape. They do all kinds of things. So just figure out a way to position it. Oftentimes, even a little table, or I'm sure you can figure out something. Just be creative.
We'll work you through it.
It'll be fine.
The setup room will work you through it.
We have not ever not been able to figure out something for folks. But take your time beforehand to save some time.
You do have to figure out a way to have the cell phone position kind of over the back of your shoulder.
Yeah.
Well, we need to see. Okay. So I mean, it could be over your head, sort of behind you looking down. It could be, I mean, we did one yesterday like that.
Okay.
But the point is, we need to be able to see your computer screen. Why do we need to see the computer screen? Because we want to make sure that you're only seeing your examination presented, and there's not some other pop-up, a calculator or some other thing there.
There's too many crafty people out there to allow the cheating to happen, and that's why the second camera is required.
And and the reality is we have had people attempt to cheat, which is mind-boggling to me, because this examination, if you put that much effort into figuring out how to you pass the exam legitimately, it's actually probably less effort than trying to cheat and then get yourself in hot water with the feds. Because you cheated on a federal examination. That wouldn't be good, right? So anyway.
All right.
Can I add something?
Go ahead.
This is field day weekend all over the country, right?
Yep.
So I'm planning to go to the local field day and take this in person.
Excellent.
So and especially because I'm on the East Coast, I don't want to be doing this so late on a Friday night.
Mm-hmm.
So if other people are finding it difficult in one way or another, there's probably a field day near them.
Wait, I'm sorry. I thought the test was 2 o'clock tomorrow afternoon.
Depends on where you're at.
Is that PST?
A specific time.
That is PST.
Oh shoot!
Or
So
no,
I
it's
need to go early.
It's PDT.
Right,
Yeah.
PDT.
Yeah,
But
I need to be. I need to go early. I thought it was.
can you get her in the
12 to
morning?
3.
Is there a slot in the morning?
Let's hang on just a second. Let me.
I thought it was the same time as the class.
No, it was done for availability. So
it's on completion of the class.
Yeah.
Well, I
So-
think the other thing to consider is I think they're changing all the questions
At the end of the
end of the month. So
Yep.
unless you get it done now or between now and the end of the month, you got a whole bunch of different questions that you may or may not have.
Fundamentally, it's going to be the same, but
There's about 30 to 35% of the questions are changing.
yeah.
I'm
But I've
just
taught
checking
you
the
guys so
schedule.
much background information that it'll be easy.
Is it getting harder or easier?
Neither.
They update it to current technology, to
Yeah.
current things and whatnot. So, yeah.
So we've still got quite a bit of stuff to go here,
Yeah.
but we're going to get it. We got 2 hours, and I'm just telling everybody right now, I might go a little over today.
Let's see, who was asking
That
the
was
question about
Jill.
Jill.
Thank you.
So, yeah, it starts at 2 o'clock your time. We're full up on the morning session. Let me see something here.
Could you squeeze another one in?
Yeah, we can get you in the morning, Jill.
I'm in Vermont, so East Coast.
Yeah. Okay. Let me send you an email on you. I want to make sure you're actually registered with us, right?
Yeah.
Okay. Yeah, I'll get you registered for the morning session, the earlier session. It'd be we start at 1:15 Eastern time.
Great.
That gonna work? But
Sure.
we might have to stack you. We got 3 other people testing. So you might be after one of those, okay?
Okay, thank you. Thanks so much.
But I'll get that taken care of right now.
Thanks, Kent.
All right.
All right. We're going to roll back into this material.
Okay, bye, everybody.
Wait, can I?
Wait.
Thank you.
Wait.
All
Wait,
right.
you got another question. Go ahead, Knight.
Yeah.
Yeah, I'm gonna register like right after this class because I was
Yep.
like just taking the practice exams, making sure that I felt confident enough so that I could pass the test before like I took it. But could I also take like the morning one? I have like an internship and it starts at like 3 Pacific time, and so like it'd be like really, really close.
Yeah.
Hey, Kent, would it help? Would it
Yeah.
help if I showed up with if I dragged Hannah to it with me? Give you 2 more examiners.
We would need more VEs. Yeah.
Okay, well, I'll sign me up for the morning. I'll sign up for the morning if there's room.
Yeah. We'll open some. Yeah. Okay. I don't know who.
That was Knight Uretsky, and he's not signed up yet.
Oh, okay.
So, but
all right.
He's doing play-by-play for a baseball team.
I see. All right.
And they play
I'm gonna okay, so Knight.
Yeah.
I'm gonna open up a morning slot in a minute here, and you're gonna want to go in and get it.
Okay.
Okay, right away. Because when I open it up, it's opened up to the world.
Yeah, hang on.
Let's see, and that's Anchorage.
If you get to this page, let me edit this right now. This is for the 24th.
And thank you, Kent.
Problem.
And here is remote testing page.
Okay, and refresh the page and go. There should be a slot showing for the 24th morning right
Okay,
now.
where do we get there from it?
You got to go to the bottom there and click the register link.
Oh, link register for an exam. Okay. Okay, Knight, I'm going to forward you that page. Okay? Okay. I'm going to go to chat, and there's Knight, and here it comes. Nope, that's not it. Why is that not right? Don't go there.
Here, I can put it up here.
There we go. I got it now. That was weird. Okay, here it comes, Knight. Do you see it?
Yeah.
Okay. So click on that.
And if not, there's the link in chat.
Yep, it's the same one, I think.
And let's see.
Yeah.
Yep.
And Jill, let's see, is it
Werfel.
Jim? Yeah, Jill. I'll get you moved. Jill, don't worry, you're already registered, so I'll just move you. Okay.
Thank you.
Okay, guys. Thanks
All right,
a lot.
Cool. Let's get back to
Good
studying,
luck,
shall we?
everybody.
All right.
Yep.
Hey, remember, listen, we're all rooting for you. We're on your team. Okay, you're going to be with friends. Don't worry about don't sweat the exam. We're hoping you all pass. Okay, good luck.
Hey, there's a question in chat right there from Izzy. Do you see that?
No.
It's like, I know she's asking about her brother being dyslexic.
Oh,
and I
oh, yeah.
understand that because of my ADD.
Can we get questions being read? He's not signed
Okay.
up. But
Okay, so for that, so no, you can't help him read the, well, what'll happen is if he needs help with that, then we will have someone read the questions. The reason we do that is because we have to make sure the questions are presented in the right manner. So if that needs to be done, when you register, we ask a question, do you need special accommodation? And this would be that sort of thing, okay?
all right, let's back to studying, everybody. Kent,
Good
thanks,
luck.
man.
Bye.
All right, let's do this. Okay, common transmitter and receiver problems. We're on page 62, and we have to get to about 88. So, here we go. Which of the following can cause radio frequency interference? Fundamental overload, that's kind of what we talked about with a handheld radio with no filtering on the front end. That's basically, it's just getting too much stuff coming into it, and it can't receive anything. Harmonics. A harmonic is basically an integer multiple of a frequency. So if my main frequency is 10 megahertz, my harmonics are 20, 30, 40, 50, 60, and so on. Spurious emissions. Those are things that are unrelated to any other frequency. But any transmitter can go into a mode if it starts to develop self-oscillation in the transmitter output and start developing spurious emissions. This is what very often can cause interference with other services like the fire department or air traffic control, and you'll find out about it if that happens.
What is self-oscillation?
Literally, what makes an oscillator? An amplifier, and an amplifier and a capacitor and an inductor. Those things put together make an oscillator. Okay. And if you don't neutralize a transmitter can suddenly start. It's not common, but you can.
What page is that on? I'll go study it.
Page 62.
Okay.
Basically, you can get a spurious emission, which is caused by self-oscillation. If it's a vacuum tube amplifier or something with two separate output transistors, you often have to neutralize the output in order to eliminate self-oscillation.
Vacuum tube amplifier?
Yeah, we're not doing them here, obviously, but which of the following actions should you take if a neighbor tells you that you're interfering with the cable TV or TV reception or radio reception? Basically, you should make sure that your station's functioning properly and it doesn't cause interference on yours. Once you've established that your station is functioning correctly, the big question is, who is operating legally, you or them? And the answer is both, but who has a license?
You do.
You do, which means if you can prove that your stuff is operating correctly, you are a licensed operator in a licensed service. They are not. They are something called Part 15. A television, if it's being interfered with, has to accept all interference from all licensed services. So, are you obligated to help fix your neighbor's television? You are not.
Oh.
You might want to do it. You might want to help them out because you can, but you're not obligated to. Now, if you find that a neighbor's TV, their plasma TV, is interfering with your ability to operate because it's wiping out your receiver, guess what? You can tell them to shut the damn thing off if you can prove that that's the problem.
Who enforces this?
This is the FCC.
So you would actually have to drive a complaint with them to get any
well,
sort of...
ideally, you would say, look, you're doing this. The next thing is that we're going to go to the FCC. So you might want to turn it off when I ask you to turn it off, because I am a licensed service and you're not. More than likely,
Oh.
they're going to do it.
So how does this really happen?
Yeah.
That they,
Oh, yeah.
if I'm not interfering with my own TV,
Then it's their
how
problem.
how could I be interfering with their TV?
They're totally different. They're built differently. You know, there was an old school method of figuring out whether or not how to save money on things. They'd basically take a TV and they'd just start removing components until it didn't work anymore. And then they'd put it back. Well, said, well, obviously that other one, that wasn't necessary. So they start making it without it. What that means is it then becomes less robust. And, okay, well, 99% of the time it works, but then suddenly it doesn't.
Okay, so it's actually the particular TV they have is susceptible to interference, and mine is not.
Exactly.
Okay.
It could also be the wiring that it's connected to. You know, it's connected to their house wiring. Yours is connected to your house wiring. They are totally different things in different locations. When you transmit, maybe it's affecting yours, maybe it's not affecting yours. It's hard to say.
Okay. Understand.
What should be the first step to resolve cable TV interference? F connectors tend to loosen, so you want to make sure that all the connectors are nice and tight. A broadcast AM or FM radio can receive an amateur radio transmission unintentionally because it's unable to reject signals outside of its band. The easy way to describe this and how to fix it is, let's say that here's our frequency from 0 to infinity, and here's the FM band that it goes from 88 to 108 megahertz, and you're transmitting way up here at 146, and all of a sudden you're interfering with an FM band receiver right here. So if I were to build a filter for this, I would do this. I'd make it so that it allowed frequencies between 88 and 108 and rejected those frequencies above. This would be called a band pass filter. If it allowed only lower frequencies like this would be called a low pass filter. If for some reason I wanted to allow only higher frequencies like this would be called a high pass filter. Now I could also build a filter that looked like this. Well, what does it look like has been taken out of that?
Notch.
That's called a notch because it looks like a notch. So I could actually build a filter that allowed everything except one particular frequency and put that on my receiver, and that would be called a notch filter. You can also cascade these one after another and build all kinds of cool filters out of that. Filtering is a really important thing that comes from this device and this device. Everybody remember those? What are those called?
Capacitor.
Capacitor and an inductor.
Inductor.
And because they're frequency dependent devices, you change the value of your capacitor or inductor and you can tune it to a certain frequency and make it behave in a certain way. Very cool stuff. How can overload of a non-amateur or TV receiver by an amateur signal be reduced or eliminated? You install a filter. Let's say that you have a telephone that is being interfered with. What would you put on the telephone? It's that same word that starts with the letter F. Get used to it.
Filter.
A filter. Okay.
So now, are you talking about applying to the physical cord coming out of the wall, or
Sure are. When you put an RF choke on something, that's an RF filter too. So it could be a capacitor, it could be a choke, it could be some inductance, it could be any number of different things. Basically, it's a filter. Does anyone remember actually having a wired telephone that plugged into the wall? You rented it from the phone company. If that got interfered with, they actually owned it. They would actually come out and put a filter on your telephone line. A band reject filter could be used to reject a certain band of frequencies. That could also be known as a notch filter. A Part 15 device is any device that can emit low-powered radio signals and also accept interference from licensed services. If something in your neighbor's home is causing interference to you, you work with your neighbor to find it, You inform the neighbor about the rules that prohibit devices that cause interference to be used, such as we have a lot of people having marijuana grows around here. They buy grow lights. Grow lights can, depending on where they're from and how they're made, be an enormous source of radio frequency energy that causes all kinds of splattering. And they run about 12 to 18 hours a day, depending on the person doing the grow and where it is in the cycle. So the FCC has actually cracked down on people using unlicensed or untested grow lamps for their marijuana grows. The other thing to do is make sure that your station meets the standards of good amateur practice. So make sure everything is nice and all the cables are nice and tight. Make sure that the frequencies are where you're supposed to be, and so on and so forth. If someone says that your audio signal through a repeater, so we're using our FM radio, is unintelligible or distorted, it could be that your batteries are low and you're not generating the frequency, you're not generating the voice the way you're supposed to. Your transmitter could be slightly off frequency, or you could be in a bad spot, in which case you'd have, if you remember from a couple days ago, multiple signals getting there at different times, causing cancellation of your signal. RF feedback, if you get radio frequency energy back into your microphone, what you'll end up with is garbled, distorted, or unintelligible sound. If your FM or handheld or mobile transceiver is over deviating, that means you have too much audio signal going into it. It means you have too much mic gain. This radio doesn't have a microphone gain control. So again, what is my microphone gain control? Pull it away from my face. Exactly right. Or if it's not loud enough, you put it closer to your face or yell into the microphone. Which of the following measurements? We're on to meters, page 65. Which of the following measurements are commonly made using a multimeter? That would be voltage and resistance. You can also measure current. Something that measures voltage would be called a voltmeter. Something that measures current would be called an amp meter, or an ammeter for short. Something that measures resistance would be called an ohm meter. So what I'm going to do is share, if I can find it, this web page I was looking at. There we go. Okay, so what I have brought up are two multimeters that you can go and buy today. Notice we have the Centec 7-function meter, which says can operate from 200 to 1,000 volts. And we have our Fluke digital multimeter 6000, which instead of $7 costs $600. And it also has an operating range of, I believe, here we go, 1,000 volts. So which is a better meter and why? And which would you trust with your life, everybody?
I'll take the Fluke every day.
I own a Fluke. I use it at work. Why would you do that? Because this meter costs literally $6, and those leads that are connected to it, those wires, may or may not actually be good at holding 1,000 volts and keeping you from either blowing the meter up or getting electrocuted.
Those used to be given away at Harbor Freight.
They did. They would give them away, and they still do sometimes. Whereas this meter has actually been tested. This is what I use at work when I'm measuring 480 volts. I've never had one blow up on me. I do know people who've had these blow up on them. I wouldn't mind testing 24 volts with them. I would actually still use them at 120 volts at home just to measure the wall voltage, but I will always wear rubber gloves when doing this. What's the proper way to connect a voltmeter to a circuit? You put it in parallel with the circuit. So when you're measuring voltage, I would do this. If I have, let's say, a resistor, and I want to measure the voltage, I would put my meter right here across it. Because I don't want to affect the actual circuit. I'm just seeing how much voltage exists across it. Now, if I wanted to, for instance, measure my resistor, and so I would put this on the ohms setting. Well, if you think about it, the ohms setting, it uses E equals I times R. Well, in order to measure R, that means R is equal to E divided by I. Well, in order to do that, I can measure my current, but I have to know how much voltage went into it. If this is connected to this battery, do I know how much voltage is in the battery?
Yep.
No, I don't. I don't know because, well, I know, but the meter doesn't know. So what we would do is we would disconnect the battery from the circuit. And then, because there's no path for current around this, essentially all of the test voltage, that's why an ohm meter has a small battery inside it. This generates a test voltage, which then creates a test current through here. So if I know that my E exists and my I exists, I can calculate what my R must be. And that's how an ohm meter works. Now, what would happen if I tried to test a circuit that was powered? I would get a very confusing result. And the meter, first of all, the meter could blow up. Secondly, the result that I get would be very, very unreliable. Let's see. That's why when you do that, you must be sure. Now, here's the other question. Let's say that this was here, and I do this, and I have the resistor, and I also have it shorted. What is my measured resistance going to be?
0.
Yeah.
It's going to be 0.
0.
Because it's going to follow the path of least resistance. Well, this is a short circuit, so it would go that way. And I wouldn't get a reading at all. If there was a resistor actually in here that I didn't know about because I forgot to disconnect this circuit, I would get something in between. The other thing is, if I, let's say, didn't know what was in there and I forgot to do this and I tested it out and it turned out that there was a capacitor in there, what would happen is the capacitor would charge up and then be fully charged. And while it's charging up, it's like a short circuit. So over time, what would happen is my measured resistance would be 0, and then it would look like that. It would actually change over time as the capacitor charged up. That's how you can tell, oops, there must be a capacitor in my circuit. Device used to measure electric current is an ammeter from amps. And there's a couple of different ways to do this. An ammeter, unfortunately, for the most part, actually has to go in line with the resistor. Now, if you're unfortunate enough to have your meter set to the wrong setting and you put it right here, then you blow a fuse in your ammeter. I have done this several times. In particular, if you have it set to ohms or volts and you put it in line with the resistor and the battery, you'll blow up the fuse in the meter. Now, if you don't have a fuse in the meter, because it's a cheap meter, what will happen is your meter will go like this and you'll let all the smoke out. And once you let all the smoke out, the meter doesn't work anymore because the smoke is the magic stuff that makes something work. And once you let the smoke out, you can't get it back inside. Anyone ever heard that before?
Magic smoke.
The magic smoke. The magic smoke is the stuff that if it comes out of a circuit, the thing doesn't work anymore because you can't stuff it back in.
It tends to linger.
Yeah, it does. It smells really bad.
Hey, Scott,
Okay.
it's Kent.
Hey, Kent.
Sorry to bother you. I just needed to let Jill know. I got her straightened out tomorrow. Jill, it's in your chat. Sorry about the
Awesome,
errors.
thank you.
And Knight? Is Knight in there?
Yeah, I
Wonderful.
heard.
Yeah, he's on there. Thank you. Sorry to
Awesome.
bother.
Okay, awesome. Thanks, Kent. So Kent's off to do another exam this morning, actually. They do them twice a day. When you're soldering something, we always use rosin core solder. A nice flowed solder joint is nice and shiny. If it's dull and grainy, that means that it's cold and the solder didn't really melt. If the solder didn't really melt, it's a mechanical connection only, not an electrical connection. And it might work, but it also might not. If it's going to decide to not work, it's typically when you need it to work the most. All right, we're on to page 67, operating procedures. Okay. What type of amateur station retransmits the signal of another amateur station on a different frequency? That's known as a repeater. It's literally like a person standing on a mountaintop, hearing everything and repeating it. There are 3 different kinds of stations that can retransmit the signals of other stations. Those are a repeater, an auxiliary station, which would be something on a mountaintop that just is like a forwarding station that would basically be used to like link one system to another, or a space station. There's actually a repeater station set up on the International Space Station, which you can actually work with a handheld and a 3-element antenna that you can hold in your hand. You can talk to people on the space station. You can talk to other people on the ground that are pointed at the space station as well. The common repeater frequency offset in the 2-meter band is plus or minus 600 kilohertz. In the 70 centimeter band, it's plus or minus 5 megahertz. We talked about this a little bit. There's something called PL, which is private line, or Ctcss. And that's the use of a subaudible tone, one of typically 38 tones that allows a particular repeater to listen to you and nothing else. Let's see. This happens all the time. In Eugene, we have something called the Now What Net, which is a beginner's net on Monday nights. And we see all kinds of problems that people forgot to do something. So if you can't get heard by a repeater, even though you're really close to the repeater and you should be able to get heard, the offset could be wrong, right? We end up with people transmitting on the repeater output. We can kind of hear them, but as soon as a repeater comes on, it completely wipes them out because they're not transmitting on the right frequency. So they have the offset set wrong. The repeater might be listening for a Ctcss tone, like 100.0 hertz. If you're not transmitting with the right tone, you won't break the repeater squelch. The same thing with a DCS, or digital coded squelch tone. If you're not set up properly, the repeater will say, nope, I'm not listening, and won't retransmit you. If a station isn't strong enough to keep a repeater squelch open, such as that same person who is, let's say, a mile from you, but is in a valley and they can't get into the repeater, it might be possible that you can listen to the same frequency that the repeater is listening to, and you might be really close. If you're really close, you might actually be able to hear them directly and establish direct communications. In fact, that's known as Simplex, and we actually practice Simplex every week around here in Eugene. We run a Saturday net that is a Simplex net, where people intentionally operate without the use of a repeater because you can't always guarantee that there will be a repeater. And then we practice talking to each other using nothing but terrain. So that might be somebody has a big antenna, somebody's on a hilltop and can function as a net control station that basically can hear everybody and retransmit signals to everyone. The most common use of reverse split is to listen on a repeater's input frequency. So you intentionally switch your receive and transmit frequency. So you're listening on the repeater input. That way, again, you can hear stations that might not be loud enough to get into the repeater. If somebody says your transmissions are breaking up on voice peaks, that could mean, again, you're over deviating, you're talking too loudly. And the solution? Back away from the microphone. How would you call somebody else who has a license on a repeater? You use their call sign, then your own call sign. So Chuck, if I'm calling Lisa, I'd say W7LJP. This is N7JI. That's it. That would mean that Lisa knows that I'm calling Lisa. You say the station's station's call sign, then your own. The easiest way to identify that you just happen to be listening on a repeater and listening for a contact is you say, this is N7JI. In my case, I would just say, hey, I'm here. If anyone would like to talk, I just told you I'm here.
Oh, by the way, can I get a list of call signs that are taken and find out if what I'd like to get is available?
We will get to that. And actually, after we remind me after we finish this, I'll show you how to do that.
All right.
Let me forget.
Thanks.
Okay. Talking on the same frequency, transmitting and receiving, is known as simplex. Only one station can talk at a time. Even if you're operating duplex through a repeater, only one station can talk at a time. It's actually not like a telephone. It's called half duplex. Why are simplex channels designated in the VHF-UHF band plan? The reason being that there are many times that a repeater, if you think about it, is a resource because many people can use it. If you don't need to tie up the resource because you're only a mile apart and you don't expect to be talking to anyone else, it makes more sense for you to talk directly from point to point if you know that that's a reliable path. The national simplex calling frequency. Sometimes you'll actually see this on the back of a car. They'll have an oval sticker and it says 146.520. It's a reminder. This is the national simplex calling frequency. Anywhere in North America, there is usually somebody listing on that frequency. And this is a simplex frequency, so it's not a repeater. You would be transmitting and receiving on the exact same frequency. And again, in the US, this is the national simplex calling frequency on the 2-meter band.
So is it like channel 9 for CB?
Yep. Everybody scans it. Everybody has it programmed. Okay, we're into HF operation, which is page 70. What is the meaning of the procedural signal CQ? It means literally, I seek you. I'm looking for somebody to talk to, calling anyone.
Scott, before we move on, you mentioned this 446.0 or any of those frequencies. Are those, do they have any modulation like AM or FM? Or
Well,
is it just...
Oops, I picked up the wrong thing. They are, if we look at the band plan, where's the band plan? Where did I put the band plan? Okay, so this doesn't really show it. Let me pull up the band plan. Band plan. Sorry, I got to unshare and reshare. Share alike. Okay, this is the band plan. Notice on the 2-meter band, it says FM simplex. It's the pink areas. So there you go. You can see where the pink areas are. Now, a band plan, with a very few exceptions, notice we have these red swaths down here for CW only. Those are actually on 2 meters and 6 meters, codified into law that they're Morse code only. But everywhere else, the band plan basically says that that's a gentleman's agreement. I apologize for, if that insults the ladies. It's a how about a gentle person's agreement that says that in order to keep the peace on all of these bands, this is what we're going to follow. And these can actually be subdivided even further. There's a group called the Oregon Regional Relay Council, or Radio Relay Council, which handles band planning and assignment of frequencies to certain repeaters in the state of Oregon. There's another one in Washington. There's another one in Idaho. There's another one in Vermont. Basically, that group, which is known as the frequency coordinator, is responsible for setting up how these frequencies are going to be subdivided in a particular area.
So 146.5 will be an FM repeater.
Nope.
Then. Nope.
It'll be the pink. So that'll be FM
the simplex.
So notice it'll say between 147.6 and 148, those are orange, that would be an FM repeater. And in fact, those repeater frequencies are paired with what is between 147 and 147.4. So that because you have to be 0.6 megahertz apart. So there are pairs that exist between this section and this section up here.
So the FM simplex, the band between 0.4 and 0.6 is to allow the modulation of FM?
No, it's all FM.
Simplex?
It's all FM. Now, the channel spacing is about 20 kilohertz, 15 to 20 kilohertz, to allow for the fact that that's the width of a channel. That's the width of an FM signal.
So this purple, or I guess it's pink, between the 0.4 and 0.6, it's just like one channel for this?
No, there'll be 146.4, 0.42, 0.44, 0.46, 0.5, 0.52, 5.4, 5.6, 5.8. So it's every 20 kilohertz. There's another channel.
Okay, thank you.
Mm-hmm. Now, again, there's nothing saying. One of the reasons why amateur radio is different is that, let's say that you have a radio that tunes continuously between 144 and 148. If we have, let's say, a channelized service like Family Radio Service or GMRS, those are channelized by law. You are only allowed to operate on certain frequencies by law. We are allowed to tune our equipment anywhere between the lower edge and the upper edge, so long as our signal is completely contained in the band.
So can a ham operator operate on the GMRS spectrum?
No. But what we can do is we can say, okay, well, I need to operate on 146.49 or 495 or 4952. I can tune my radio, I can tune my frequency to anywhere so long as it's inside the whole band.
For a technician license, can we operate on each and every one of those frequencies that shows on this sheet?
Yep.
Including the HF?
Only if it says novice or technician.
So that's just in the HF.
That's
and the VHF and UHF were everywhere.
Yep. Okay. But then again, this is why there's something called incentive licensing. If you want more privileges, you go study more. And you can use more of the band.
That makes sense. Thank you.
Yep. Okay, HF. Let's see. What do you do when looking for a frequency? Well, you make sure that you're allowed to be there and transmitting. Then you listen and listen and listen some more to see if there's anyone there. And then you ask if there's anybody there. Because it's entirely possible that somebody might be using it. And because of propagation, you can only hear one side of the conversation. And you don't want to interfere. The answer to that would be, yeah, sorry, I'm already here. Or you don't hear anything, then you're free to start using it. How would you respond to a station calling CQ? You hear CQ, CQ, CQ. This is N7JI. Listening for a call. Hey, Mark. Go ahead and answer me. CQ, CQ, November 7, Juliet, India. Listening.
Trying to find my unmute button. Sorry, say again, mate.
CQ, CQ, November 7, Juliet, India, N7JI.
N7JI, this is VK4MHQ.
Okay, Victor Kilo 4, Mike Hotel, Quebec, November 7, Juliet, India. Good afternoon. Apparently I'm making it all the way to Australia today. And beautiful day here in Eugene. And you're a nice solid 5 and 9 signal, over.
Thank you very much, Scott. It's a pretty cool night here in winter in VK land in Australia. And it's still dark outside, so I can't tell you what the weather's doing. But your signal's 5.9 into my radio.
All right, thank you, Mark. Well, I'm going to go and take another call, and I appreciate it. And have a great, have a great morning, early morning.
You too.
This is November 7, Juliet, India, 7-3.
You too, Scott, 73.
Okay, this is N7JI, listening for any other stations. So basically, that's a conversation. So you can talk about the weather, you can talk about the fact that you have a doctor's appointment. God, my sciatica is acting up. You know, things of a personal nature are very good to talk about. You don't want to talk about religion or politics. And you don't want to use any language that would offend your 8-year-old grandson or granddaughter. Okay, because you never know who's listening. Okay, what's the following is required when making on-air test transmissions? You use your call sign. You just identify the transmitter. A Q signal. There are many Q signals. There's the Q signals came out of Morse code. They are canned information. So a QTH is my location. QRM is man-made noise such as interference. QRN is natural noise such as lightning or static crashes. QSY means let's change frequency or I'm going to change frequency. Notice these are, because they came out of Morse code, 3 letters. Takes up a lot more than spelling something long out. So the ones that you need to remember are QRM and QSY. QRM means M for man-made noise. QSY means I'm going to change frequency. Or you can pose it each of these as a question. QSY question mark. You want a QSY? Sure, let's QSY. It means the same thing just as a question.
What was the QRN?
QRM or QRN?
The N.
N is natural noise. So static crashes. Okay, what's a band plan? We kind of talked about that. Beyond the privileges established by the FCC, a band plan is a voluntary guideline for using different modes or activities within a band to keep the peace. And nobody owns a frequency. Common courtesy prevails. No one has any right to any absolute right to a ham frequency. All right, we're into public service and emergency communications. The Amateur Radio Emergency Service. Okay, so there's really two different things that operate in parallel. There's ARES and there's RACES. They both have this ES, which stands for Emergency Service. ARES is Amateur Radio Emergency Services. RAC is Radio Amateur Civilian Emergency Services, or Radio Amateur Civil Emergency Services. So this one, ARES, is a volunteer organization that's typically run by the ARRL. RACES is one that is typically run by your local civil defense agency. Typically, if you operate in one, it's very easy to operate in the other. So essentially what each of these is a combination of people, equipment, and frequencies for public service. Specifically, RACES is the one that's set up by your state emergency coordinator, like working for the state government. Whereas ARES is a totally volunteer organization that's set up by the ARRL. And again, there's actually a lot of overlap between the two. If we're talking about a net is short for a network. And if I were to set up a net, I would have this person in the middle called net control. This is net control. Net control has the ball. Net control determines what the traffic is that's going to pass between points. So let's say that I have station A and station B and station C and station D like this. And there's a network, an ad hoc network, that we've set up either using Simplex or using a repeater station. And net control basically is the traffic cop. Typically, the net control station determines who can talk to who, when, where, and why, and is the central clearinghouse for information. Formal information that travels through a network is known as traffic. And typically, when you check into a net, you say, basically, I am, unless I need to get out of here, I am available as a resource for net control. So your job is really, unless you need to go somewhere else, you're supposed to log in, check in with net control, and then stay on frequency unless you have to go. If you want to get the attention of net control, you would say either break or emergency. Because the way that a net works is that since everybody's using the same frequency, if somebody just starts chatting, let's say that station B and C just start chatting away on that frequency, other stations won't be able to use the frequency anymore. So the way that it works is that you don't speak unless spoken to, unless you have a reason to get the attention of net control. So traffic is these little red lines. Traffic passes from person to person. Typically, the net control station is going to have the ball and determine who can talk to who. So station D might say, hey, I have traffic for station B. And so it might be that they say, okay, station B, can you hear station D directly? And the answer is yes. They say, okay, station B and D, go ahead and exchange your information directly. And then pass it back to net control when you're done, so that I can take over again. So basically, that's how a net works. We do a lot of practice with nets because one of the main reasons that we exist, if you look at the FCC rules, and that's in Part 97, once again, Part 97 is the ham radio rules in the FCC. in the Code of Federal Regulations. Part 97 is what allows us to exist. It's what allows us to have our licenses. And it specifies the things that we are supposed to do with those licenses. Part 97 specifically says we're supposed to be there in times of emergency. Well, the way to get good at knowing what to do in times of emergency is to practice when there's not an emergency. So we run nets. We run frequent nets. Sometimes these can be with made-up traffic. Sometimes we just put a net together and say, let's talk about the weather, or how is everybody doing, or what's for lunch today. We actually have a net on Friday afternoons in Eugene at lunchtime, which is a lunchtime net. And we just basically talk about food. But it gives us practice in talking to other people at a scheduled time with somebody who's operating as a net control station who gets to run traffic cop, and that person rotates so other people get to practice.
Scott, quick question. In your previous diagram, how would D get the attention of NCS to communicate with B?
That's a good question. Because it might be that, I'm going to draw this again, it might be, let's see that here's net control. We could have a distributed net where you have A and B, and I can't remember, I think C was here and D was way over here. Well, it might be that we know, for instance, that let's say that D is outside of the range of control of net control. Net control knows that the path for information to get to D would be to go through C. This would be known as a relay, where you could say, I'm going to use one of the resources, which is station C, and I'm going to exchange information. Let's say it's from E to D, right? They can't hear each other. So E passes information to the net control station, which says, okay, I know that station C can hear station D, so I would pass that information over to station C and say, station C, I need you to be a relay, send the information to station D, and please confirm when you got it. Okay, well, this one basically becomes a temporary net control and handles information between C and D, and then reports back to net control saying, okay, they got it. And then I would report back to station E saying they got it. So this kind of thing, actually, there's something called a radiogram, believe it or not. People still send messages over the radio as practice for when there really is time that there's an emergency, such as, you know, there's an earthquake or a hurricane in the Caribbean, and somebody sends 20 ham radio operators down there with equipment and says, go collect information and send back all the names of people who you know are okay, because the cell phone networks aren't working, and this actually happened about 3 years ago. So they were basically dealing with health and welfare traffic and letting people know that their relatives were alive. When that was the only way to get information in and out. Okay, so that's network traffic. Which of the following is a characteristic of good traffic handling? That would be passing messages exactly as received. And you may say, okay, well, what's the point of using the phonetic alphabet? Okay, who here's got a tough last name? I'm going to pick Knight because his name is Yaretsky. Now, if I were to say Yaretsky, I could say it's Y-A-R-E-T-Z-K-Y. Right? But that's probably not the right spelling. So if I were passing that information across and say the name is Yaretsky, I spell Juliet, Alpha, Romeo, Echo, Charlie, Kilo, India. I would spell it out phonetically so that the exact spelling went across. So phonetics are very important to know, and we use the ITU standard phonetic alphabet. What information is in the preamble of a formal traffic message? That's where it came from and where it's going. So information needed to track the message. What is meant by the check? The check is a number of word equivalents. So if the message is see you at the zoo, period. Okay, I would also send see you at the zoo and a check of 5. And if for some reason, at the end, I had gotten a message that was only 4, I'd say, well, okay, I only got 4. Please resend it. That's known as the check. It's also known as a checksum. It's the same thing that we do with digital communications, except this is with voice. When do the FCC rules not apply to operation of an amateur radio station? The answer is never. The FCC rules always apply. When are you allowed to operate outside the frequency privileges of your license class? That also includes, let's say, outside of having a ham license at all. The answer is if in situations, and this is very important, in situations involving the immediate safety of human life or protection of property. Okay, there was a wildfire recently in Idaho. I believe it was last fall. There's a ham who lives in Idaho who took it upon himself to pop up on the wildland fire department's frequency and report to them where the fires were. He was just fined $38,000 by the FCC for willful interference of a licensed service. The question is why?
It wasn't immediate.
It wasn't immediate. In other words,
There's 911.
Yeah, he could have gotten on his phone and said, here's the report of where the fire is. It's building here and it's building there and the smoke is going in this direction, and please let the fire department know. He could have done that, but he took it upon himself to say, in my opinion, this is an immediate need. But in reality, it wasn't, and most reasonable people would have said, this is not immediate. There's not like somebody who's about to die, or there's a house that's about to burn to the ground. Right? It was just information. So that he got fined $38,000 by the FCC for transmitting out of band and thus using frequencies that he was not allocated to use.
Because it was not imminent to life or property.
Yep, exactly. And there's actually been a lot of discussion about that on the message boards that I read. So there's your catch-22. The FCC rules apply, but you can't violate the rules unless it's immediate safety of life or protection or property. Has to be immediate or imminent. Okay, we're on to amateur satellite operation. Okay, which amateur radio stations can make contact with an amateur radio station on the International Space Station using 2 meters and 70 centimeters? That would be any station holding a technician or higher class license. So the question is, why do they say technician or higher class? Because you notice right here, there is something called a novice, right? Everybody see that word novice? You could actually get a novice until the late 1990s. A novice license is actually a lower license class than a technician class license. As a novice, you do not have access to most frequencies in this band, which is why they have to say that. It's important to know that a novice license still exists. And in fact, in the last 2 years, I've actually had 2 people with existing novice licenses come here and do license classes so they could upgrade to technician. So this is not for them an entry-level license, even though it is for you. What is meant by a satellite operating in mode UV? Okay, does everybody remember what the difference is between HF, VHF, and UHF?
Yeah.
Okay.
High frequency, very high frequency, and ultra high frequency.
There you go. And high frequency, HF goes between 3 and 30 megahertz. VHF goes between 30 and 300. UHF goes between 300 and 3 gigahertz. So a satellite that's operating in mode UV means that the uplink to the satellite is in the U band, UHF, and the downlink back to the ground is in the V band. Typically, the most common frequencies that we find in those bands are going to be the UHF band that we use is going to be 70 centimeters, and the VHF band downlink is going to be 2 meters. So the repeater station on the International Space Station is a mode UV satellite station. The type of the modes that are very often used by satellites, you can use FM. The ISS uses an FM repeater. You can also use Morse code. You can also use data, or you can also use single sideband.
Quick question.
Yep.
Going up to the satellite, you're using UHF because it goes through the ionosphere, but VHF because it's not the same concern.
The reason that you split, I mean, you can do VHF up and VHF down, but typically the reason that they do UHF up and VHF down, they both basically pass through the ionosphere.
Okay.
But the reason that they do that is that they can have two completely separate antennas, because one's going to be receiving at the same time that the other one's transmitting, right? Because it's a repeater.
Okay.
And if they were on the same band, you'd have to have a lot of filtering to make sure that the output didn't get back into the input and wipe it out.
Oh, okay.
So that's why they have, it could be VHF up and UHF down. That would be mode VU.
Scott, how involved would be listening to the ISS?
It passes overhead
radio?
it passes overhead every 90 minutes.
But like, as far as being able to have the right intensity.
This radio right here, I can pick up the space station on this radio with this antenna as it passes overhead. Yeah, that's all it needs. That's all you need.
Cool.
But you cannot connect to them.
Using that antenna, something that size, I've never had any luck. But using just a three element tape measure.
Oops, you're muted again, or not coming through to me.
Yeah,
here's everyone.
It's not coming through to me.
We've lost your audio, Scott.
Okay, there we go. Oh,
there we go. How about now?
Yes.
Yeah.
Okay. All right. I think I hit a button on my headset. Okay.
May I ask a question?
Yeah, go ahead.
If you bring up that chart up again.
Okay. Which one are we looking at?
The one with the megahertz spectrum thing.
Okay.
The bands. Yes.
If you go down to 60, why is that black?
Okay, 60 is a weird band. Notice what this says. 60 meters is channelized. Remember I said that ham bands are not channelized? This one's channelized. And the reason it's channelized is because we share it with the military.
Oh. So it's kind of one of those bands where you're not allowed to go on?
You're allowed, but it's shared. And we're not primary. So we're going to get to primary and secondary users in a little bit.
Oh, okay.
Yep. Okay, so let me just bring up a, I don't want to see that. Let me just bring up a tape measure Yagi. And we actually build these sometimes. And this is what I use. I roll it up and there we go. Look at that. Come on. I don't actually want to see that, but there we go. Notice that's actually a tape measure. Right? You actually build your tape measure antenna out of pieces of tape measure. Like that. It actually works remarkably well. And it's very portable. That's
and
what
cheap.
And very cheap. A whole thing will cost you $15. And I use it to make contact with the space station on a regular basis. And what's cool is if you catch it at sunset, and you can actually, we have tracking programs, but if you catch it at sunset, sometimes you can actually see the space station passing overhead, and it's really easy to point the antenna when you can actually see it.
So as far as the length of this antenna, 70 centimeter band is pretty short.
Yeah, A 70 centimeter 3-element Yagi is about this big.
Okay.
So, I mean, if you're doing that, you might want to make it like, a 5-element Yagi, because it's only going to be this big.
You're gonna make you're gonna make it a full length, not a half
What do
of
you
a
mean?
wavelength.
What do you mean?
The length of the antenna. We talked about it. Thing.
Well, they're two different things. I mean, because basically at the core of the antenna, you're going to have a dipole, which is a half-wave antenna, right? So your driven element's going to be a half-wave. Then you're going to have a reflector, which is a little longer, and then a director and a director and a director. You can have as many directors as you want. Every additional one that you add will add gain to the antenna. And the spacing in between elements is nominally about 0.2 wavelengths. So the whole thing, the length of the antenna, this is called the boom, is defined by how many elements you put on it, and by what and by the frequency you're using.
The main strip, they're going to be half a wavelength, which is 35 centimeters.
Yeah, the main part of the antenna, or this is the driven element. That's where your coax cable goes to. So yeah, on a 70 centimeter antenna, this is going to be about 35 centimeters long, which is about 13 inches.
And then the horizontal line will just be a conductive material connecting.
No, it's non-conductive. This is usually that's usually PVC.
Okay, so how does like the different element contribute if they're not conducting?
They are
Parasitic.
They're parasitic. They are in the field. So basically, you have this radio frequency energy, electromagnetic field that's generated. This one is the reflector. It's slightly longer, and when it is spaced a certain distance apart, it will actually tend to resonate and then cause a reflection back in the forward direction. That's known as a parasitic element. The same thing with the directors, which are in the front. Those are a little shorter and they're spaced, and those will actually tend to radiate at the same rate. And the spacing, they will start to basically form more, they'll sort of channel the signal more forward, and your overall pattern will now look like this. So you have a lot of gain in the forward direction. And the more elements that you put out front, the higher the gain gets. The higher the gain gets, the bigger that lobe gets, and the narrower the lobe gets. So you basically...
For those forward elements, what length should they be?
These are typically like 0.48 wavelength, 0.45. There's all kinds of optimized lengths that have been computer modeled, spacing and element lengths. What's cool about it is that if you have a tape measure, it makes it real easy to cut and make them the right length.
Yeah.
And everybody's got a broken tape measure, right?
What did you call that? A Yagi?
It's a tape measure Yagi.
Tape measure Yagi?
Yep. Okay, let's see. Yep. What happens if your uplink to a satellite is too loud? You could block access to other users. A way to see if your satellite uplink is too loud is to listen to the beacon coming out of the satellite. A beacon is just basically something that's saying, here I am, here I am, here I am. Here's my call sign, here's my call sign. My battery voltage is 17.2 volts. My battery voltage is 17.2 volts. It can be a voice beacon, it can be Morse code, it can be data, it can be just something identifying the satellite. So if your signal coming out of the satellite, because very often you'll listen to yourself with a second radio, if your signal coming out of it is about the same loudness as the beacon, you know that you're probably not going to block other people. Anybody can receive telemetry from a space station. By rule, a space station is anything that is 50 kilometers up or higher. That's the dividing line between on Earth and in space. Satellite tracking programs, we are very fortunate not only that we have satellites, we are also fortunate that we are able to actually track them. And if I go to Amsat Iss Tracker, for instance, here's satellite tracking for the ISS. Look at that. I just go to a web page and it tells me exactly where the space station is. And in fact, within about 20 minutes, there's actually going to be a space station pass right over the Pacific Northwest. So by using something called Keplerian elements, which they're named for Johannes Kepler, you will see, oh, look at that. There's a maximum elevation pass of 71 degrees coming at, notice this is universal time, in 30 minutes. So if I went outside, I'd be able to take my little antenna, track it across the sky, knowing that it shows up at a little bit north of west, it disappears a little bit south of east, and it's going to be 71 degrees above the horizon. So that is a really good pass. That would be really easy to make contact with somebody else. Or if the astronauts happen to be busy on the air, you can actually talk directly to them. So map showing real-time position of a satellite track over Earth, time, azimuth, and elevation, max altitude, end of a pass. And also satellites are moving so fast if they're low Earth orbit. Notice that that made one complete orbit of the Earth in about 96 minutes. They're in low Earth orbit, or LEO, or LEO. They're LEO satellites. They are moving so fast with respect to the ground that if anyone's ever heard a fire truck go by and it goes, that's something called Doppler shift. That Doppler shift that you hear with audio when a fire truck goes by, satellite is moving at 17,000 miles an hour, and it's moving so fast that it actually shifts the radio frequency that we're listening to. And you actually have to retune your radio depending on where the satellite is, if it's coming toward you or moving away. You actually have to change your radio frequency to be able to hear the satellite properly. What is spin fading? Spin fading is caused by rotation of the satellite and its antennas. As the satellite is moving for stability, it's tumbling. If there's a satellite antenna here and it's going like this and going like this as it gets closer and further away, or it gets obscured by the rest of the space station, you might actually lose the signal. That's known as spin fading. Okay, does everybody want a 5-minute break? I could really use one.
Yes.
Okay.
Yes.
Yes.
Yep. All right, but I think we're in good shape.
Sure.
All right, thank you. Yes.
Did he just give us a break?
Yes, 5 minutes.
Thanks.
You want to come down, buddy? You don't have to.
All right, everybody, let's start hearing questions.
So can you set up a repeater to repeat that at 146, 520?
Okay, the tricky thing is every transmitter has to do what? Everything that transmits a signal has to be what? Identified. So, yes, you could. There's no reason you couldn't, except that we're going to get into modes of control, local control, remote control, and automatic control. A repeater is an automatic control thing, which means that whatever it is, whatever you set up, it would have to identify itself. But yeah, there's no reason you couldn't. I mean, basically, you can repeat something that you hear on the air automatically.
Because even if you could link them together,
yep,
you could get your message across faster, or however.
Yeah, again, you would just, you'd have to make sure that whatever you put together, because, okay, so some people go and they buy a radio that says with crossband repeat, right? It actually has a crossband repeat function built in, but to my knowledge, there's only one radio that you can buy that has a crossband repeat function that you set up as a crossband repeater, and you can also set up to send out a Morse code ID. Technically, anything else, because it's not identifying itself, is not legal. So, does that answer that?
Yes, it did. Thank you.
Maybe with a little more information than you needed. I do that a lot. I apologize.
I'd rather have more info than not enough.
Yeah. Okay, so here we go. We're going to talk about different things that you can do on the air. So, contesting. Field day is this weekend, as was previously mentioned. Field day is not a contest. A contest technically is an event where you basically aim to get a score and compete with other people in different places to figure out who made the most contacts in a given period of time, meeting a certain criteria. So this is my log from last night. This was 1 hour of operation using Morse code, and in particular for me it was about 25 watts. So 54 contacts in 1 hour. I know I didn't win. I didn't even come close to winning, but I'm happy with the result because I'm competing against myself. I happen to be a very competitive and somewhat high-strung person, and this is a nice outlet for me because, I can't run 10Ks anymore, and I can't do any real sports other than pickleball because I'll hurt myself. But I can do sports on the radio, and I like being competitive.
You guys have lots of things going on there. They don't do anything here.
Oh, yes, they do.
They do have field day, but
yeah.
You know what? The club is like a bunch of old people and nobody does anything.
Well, it sounds like somebody's got to do something
Like
about
I've been waiting 2 years to get a class and nobody would teach one.
Well, remember that the classes, I mean, we used to do in-person classes too. COVID.
I should have been studying all this time.
Yeah, but COVID really did a number on in-person classes, and that's why
It did a
I
number
actually,
on everybody's head.
I actually had one scheduled that it was the day before the the day of the COVID lockdown. I had a class scheduled for that, and I lost my room. And I said, I better do something. So I went and got a whiteboard and some markers and said, I'm going to do it from my house. I'm going to and I called everybody that was going to come to my class, and I said, I'm doing this over Zoom.
Well, it kind of too, it's like when you see things and you're there and it's whatever, it's like, it kind of soaks in better. I guess I'm a C person. I want to
Well,
see.
but that's why I have the whiteboard. That's why
Yeah.
I do the electronic whiteboard, because I
Well,
had
I'm sorry, but your whiteboard isn't quite the same.
No, it's not.
It's
But
actually looking at the thing and the pieces and it's like, okay, this is in operation, this is this, and this
Yeah.
is that, and this does that,
But-
and that does this. and-
but here's the other thing. Most of what you're going to learn, you're going to do in person. This is a very hands-on hobby,
Right.
right?
I know when they did the bicycle thing before, I should have paid a lot more attention.
Well, but you can do it now. And you know, the other thing is that this is a really good hobby for STEM. I know somebody said they were a science teacher, right? I think she might have left. But this is about the STEMiest hobby that you can possibly think of, because it brings together a lot of different things. I mean, you can do radio astronomy with this, you know?
Honestly, I'm in like my third year of engineering.
Yeah.
In college right now, and you just reviewed in the past like 3 days 2 years of science and engineering.
Yep, I know.
That's why I have so much trouble, because I don't have an engineer mind.
Yeah, but you know what? So if it makes you feel any better, I've had people who came in who said they hadn't taken a math class in 50 years and come in and, having never studied, come in for a weekend and pass the test. So
It'll make me feel really bad.
now, you know what? But don't sell yourself short. You know, just practice and, you know, just.
So
again,
if I don't pass the test tomorrow, is there a possibility I can take it again before that cutoff?
oh yeah, you can take it you used to have to wait 30 days. You don't have to wait at all. In fact,
So
there's a chance, if you're close, that they might even give it to you again if you ask.
Okay.
Now, will they charge you again or no?
Usually not. Some organizations do, some don't.
I want to
close
take
are
an
we
in-person test.
What? Wait, we had two people there.
Sorry.
Go ahead, Knight.
I was asking, like, how close? Like, are you saying, like, if you got like 10 wrong instead of 9, they might let you take it
Oh
again?
yeah, absolutely.
I want to take an in-person test.
Okay. How do you, or when do you?
What's that?
How do you, or when do you?
How? And when?
You got to go find one. And the easiest way to do it is to look up the predominance of the remote exams has made things so much easier. I gave in-person exams every month for 11 years when I was in college and then grad school and then after that. And there's a lot of stuff you got to bring to give an in-person exam.
Oh, okay.
But if you want to do it, I mean, you just have to find the exam. If you go to the ARRL website, and by the way, I recommend joining ARRL. It's a good organization. They're who basically stands up in front of the FCC and Congress for us.
Oh, okay.
There's a lot of legal stuff that happens behind the scenes. We have all that bandwidth that we have, you know, all these things like on this giant chart. For instance, where'd it go? I lost my page. Darn it. That wasn't it. Anyway, all those frequencies that we have are very, 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 very valuable. And they're always under attack. And when I say under attack, it's literally under attack by people by agencies or companies that want to use them for other things, like telecommunications. So the ARRL is the one who goes out and sticks up for us and tries to keep that from happening, because, you know, there's room for there needs to be room for experimenters and experimentation and things that don't necessarily involve money. We don't make money. We give back things that don't require money. You know, we provide our services for free. Okay, operating activities. We're on page 77. We're going to make it, everybody. Okay, Okay, what operating activity involves making as many contacts as possible during a specified period? That's called contesting. There are a lot of contests during the year, all over the world. Some are very local, some are worldwide, some are an hour long, like the one last night, some are 48 hours. Yes, it takes a very, very unique individual to sit in a chair for 48 hours and do nothing but radio. I know a lot of people who are good at that. I belong to a club where we have a lot of first-class contesters. A good procedure when contacting another station in a contest is to send only the minimum information needed for proper identification of the contest exchange. There's plenty of opportunity for chit-chat. If you run into somebody you know, you might do a little bit of chit-chat, but basically the goal in a contest is to make as many contacts as possible, which is why field day is kind of fun, because technically it's not a contest. So there is a little room for chit-chat. But during field day, for instance, it'll say, CQ, this is W7P Papa X-Ray Lima field day. And the result will be W7PXL, or not even, it'll just be like the call sign of the station, like Kilo 7 Alpha Charlie. You'll say, okay, Kilo 7 Alpha Charlie, 2 Alpha Oregon. And then the reply will be 3 Alpha Texas. And you say, okay, thank you, QRZ field day. W7PXL. It's very rapid fire. And again, you can make it a little slower than that because it's technically not a contest. There is no prize. There are points, but they don't matter. So it's a good practice exercise, and it's a great way to kind of get your feet wet. Sit down with somebody who's really good at operating and learn what they know. A grid locator, this is one of the things that I sent out to everybody. I believe it was a grid square map. The entire world is cut into 324 grid, really rectangles, that are 1 degree of latitude by 2 degrees of longitude, and they're given 2-letter designators, starting at AA and going up to, I believe, RR. And inside each of those, those are 10 by 20 degrees. And inside each of those, there is a 10 by 10 grid, which is numbered 00 through 99. So I happen to be in grid Charlie November 84. Mark, what's your grid?
Quebec Charlie 61.
QC 61. Okay, the reason we do something like that is because it, as opposed to saying, I'm in Australia or I'm in Oregon, it allows you to pinpoint within a much tighter zone where you are.
Scott, quick question. On that grid software, you have to sign in to actually see it in detail, don't you?
What, the grid locator?
Yeah.
No, you can just, that's public information. Let's see, worldwide.
The free website.
Yeah.
Could you just put
QR?
the URL in the chat?
Yeah, I'll go to IARU Maidenhead. Here we go.
You just Google Maidenhead locator.
Maidenhead grid locator. And it looks like this.
Oh, mapability.
Yep. And I can put that out there. There are more specific ones as well. Like you can zoom in on, for instance, this is that the 18 by 18 grid. I'll put this out there. I also sent everybody a grid square map in their packet, and that looks like this.
Missed that. Oh, PDF. Okay.
Yep. And there's Alaska and Hawaii. Notice Alaska's got a lot of grids because it's really far north and they get really narrow up there. They're a lot fatter at the equator because the Earth is round, so. Okay.
So we're 84.
If you're in Eugene, if you're in the southern side of Eugene, like in Cottage Grove, you're in CN 83. If you're south of Spencer Butte, you're in CN 83. If you're north of Spencer Butte, you're in CN 84. And that goes all the way up to Salem.
Where am I?
Where are you again?
Yeah.
Waco,
Texas.
Way different.
Yeah, so like DM, where would it be? 01, 00?
Yeah, maybe.
I'm trying to picture where Waco is. Dallas is DM12.
Yeah,
Okay, so I'm like down, but straight down between Dallas and Fort Worth. It'd be right straight down.
Like DM11 or EM11, EM01.
It might be 11 or 01.
Yeah.
Or I'm halfway between Austin and Dallas.
But the cool thing about it is that if you download that app for your phone, Repeater Book, as soon as you open it, it'll tell you what grid square you're in.
What's the app? Repeater Book?
Repeater Book. All one word. And it's a free download. Okay, other things you can do. Radio direction finding allows you to find the source of interference or a hidden transmitter. That's called radio direction finding. Also known as a bunny hunt or a fox hunt or a transmitter hunt or a T hunt. Internet Radio Linking Project, IRLP. There's something called Voice over Internet Protocol. IRLP allows you to connect radio and the internet using Voice over Internet Protocol. Before you use Echolink is the iPhone-based thing that allows you to connect to repeaters like Mark and I tried yesterday. Basically, before you do that, you have to register with proof of your call sign because essentially, once you are on Echolink, you are on the radio. Your voice is popping up on the air somewhere.
So it's probably the most cost-effective option to get on without really investing money into antennas and other equipment.
Well, what it allows you to do too, it uses essentially it's like a canned internet tunnel, so that, for instance, like I have friends in Austria. I know where the repeater is that I was staying. All I have to do is dial up that repeater and I'm on the repeater. As if I'm standing there using it in Austria. So we also do that with our local repeater here. So wherever I travel in the world, I can participate in our on-air nets. Essentially, I dial up our local repeater using my phone from Idaho, which is, or from North Carolina, which is not anywhere near, using VHF, and I pop up on the repeater.
It's essentially a voice over IP link.
That's exactly what it is. Yep. How can you obtain a list of active nodes that use voice over IP? You can subscribe to an online service, use a repeater list, or find a repeater directory that has it. IRLP nodes, you typically will bring up a link using DTMF, which is digital dual tone multi-frequency, also known as touch tones. Touch tones, these buttons that allow you to dial in frequencies, that is also a touch tone keypad, which if you're transmitting allows you to send touch tones over the air. The name given to an amateur radio station used to connect other stations to the internet is known as a gateway. Okay, and now we're into my most and least favorite part of the class, which is rules and regulations. Okay, here we go. We're on page 79. The FCC is responsible for amateur radio in the United States, the Federal Communications Commission. When you get a license, it will come from the Federal Communications Commission. There are 5 things that are important that give us reasons and permission to exist on ham radio and exist as a service. Again, those are enumerated in the Part 97 rules. One of them is advancing skills in the technical and communication phases of the radio art. If you go to Part 97, it's a good idea to know where to find it. There's a copy on the FCC database or FCC website. There's a copy on the ARRL database as well, or on the ARRL website. It's right at the beginning. It says basically reasons for existence or something to that effect. A beacon is a device that's used for propagation or other related experimental activities that says, here I am, here's my transmitter ID, here's how much power I'm running, and here's my location. So other people can listen to it and say, we have propagation on this band between this point and this other point. A space station, the FCC says, it is anything 50 kilometers above the Earth's surface or higher. That would basically be all satellites. And in some cases, a high altitude balloon, if it goes high enough. When are you allowed to participate in willful interference? The answer is never. Unintentional is another story. If somebody tells you, hey, you're interfering with us, then you probably want to stop. But if somebody's really pissing you off and you just really want to jam them, you cannot do that. We have this great thing that's called a finger, and we also have this great thing which is known as a tuning knob. And if somebody really pisses you off, you take your finger and you go like this, and you turn your tuning knob and go somewhere else. Who identifies transmit and receive channels within a given area? That would be the volunteer frequency coordinator, recognized by local amateurs. There's a good rule of thumb, which is that we don't want the FCC getting involved. We are largely a self-policing hobby and service. We're a hobby and a service. Fundamentally, we are a service that also has a hobby attached to it. One of the things that we like to do is make sure that we can handle ourselves, because as soon as the FCC gets involved, things get ugly. If somebody were to say, hey, we notice that you're transmitting a little bit out of band, like here's the limit on the band, and so here's 14.0 to 14.35, and somebody said, okay, your signal was heard on this side of that band edge, and this is the legal band, and your signal was drooping over the edge. That is an illegal signal. The FCC is probably not going to care, but if you're interfering with something else that's important, it might turn out that the FCC someday does care. And it's probably a good idea, because we're self-policing, to know that your signal was heard outside the band. You might get a little note from a volunteer monitor that says, I'm not the FCC, but I'm a volunteer monitoring station, and we don't want the FCC to get involved, and you might want to watch that in the future. The same thing might happen if, let's say, that your privileges allow you to go all the way down to 14.225, and you're operating like this. And your legal band would be right in here. And then we could say, okay, well, you were heard outside of your frequency privileges. We probably don't want to do that. That's not as egregious as being out of band, because if that's just basically saying you're not following the band plan. If your signal is out here and actually out of band, that is an FCC violation. Typically, you'll get a note from somebody saying, hey, you probably want to watch that. We're self-policing. We don't want the FCC getting involved, and neither do you.
How do they usually contact you?
Usually by, these days, by email. And remembering that your information is on file with the FCC, they know how to find you. We basically have the same requirements and need to follow the rules that a commercial TV or radio station does. So if you think about it, things that a TV, like a commercial TV station or radio station can get in trouble with, can get in trouble for doing and get a fine for, we can too. The rules are the same.
From a transmission that an amateur will send, how do they identify this specific amateur?
Ooh, that's a good question. Okay. Now, it's not necessarily even a ham. It could just be a jammer or somebody. So let's say that there's a station in some location within a circle, right? We know that we think that this station that's interfering with other stations is in this area. Okay, well, the FCC is really good at this. Hams are really good at it too. We can have somebody here and here and here, point an antenna, and you rotate it until you peak the signal, and the same thing over here. Okay, well, we now know that with our higher gain antennas, this is why we do direction finding, that it's somewhere in this area. And this is somewhere in this area, and this one will rotate to there and say, okay, well, it's somewhere in this area. Well, now we've just narrowed it down quite a bit, haven't we? Well, you get closer and you try again. You move here and here and here. You point the antenna, you point the antenna, and you point the antenna. This is known as triangulation. You basically say it's somewhere in this area or this area or this area. Well, now our zone is right here, right in there.
And that's all pending that you're not mobile.
That's all assuming you're not mobile. But now the other thing is the FCC also has the ability, and they have a lot of equipment to say, okay, let's say that we're watching what somebody's transmitter looks like when it starts keying up, and it goes like this. Every transmitter has a slightly different footprint, believe it or not.
Consider it like a fingerprint.
It's like a fingerprint.
Yep.
Yep.
That would be for a certain model or for a
every
serial
build.
number one?
No, every
different radio.
Every different radio, because of the components that are built into it, they're all going to kind of look the same, but from variation from machine to machine will actually have a unique fingerprint, and they can.
Would that be coupled for a serial number or something?
They can do that, but more importantly, nobody really tests that, right? But the FCC can actually, if you're really doing something egregious, they can take a picture of you keying up and match it to another time and know that it came from this particular transmitter that we're hunting down.
That's really cool.
They are really good at doing stuff like that because, you know, a lot of times it's not a big deal, but sometimes it is a really big deal. The FCC has they have field stations, they have a lot of really good engineers and a lot of really good equipment for hunting things down. Okay, we are on page 81. The ITU is a part of the United Nations that is responsible for information and communication technology. The ITU stands for the International Telecommunications Union. Okay,
It's
so
like
now...
It's like the FCC over there.
Except that it's not. It doesn't... It's basically the overarching organization that talks to the FCC. And RSG and Ofcom in England. Basically, any nation that's a member nation in the United Nations has a group that is in communication and like a delegate to the ITU. Okay. The ITU is kind of like the boss of everybody. They don't really have any enforcement power. The countries themselves have that. But what they do is they're the ones who assign all the call sign prefixes that are unique to countries and make sure that the rules are harmonized so that one country's rules don't adversely impact another one. Okay, so we're going to look at the band plan. Okay, now this is where you got to do some memorization. 52.525 megahertz. What band does that fall in? Everybody, just feel free to blurt it out.
6 meters.
6 meters. Yep. Okay. Now, the question might be, what frequency band does 49.99 megahertz fall in? Does that fall anywhere in a ham band?
No.
It does not. That's actually a totally separate thing. Even though it's very close to 50, it's on the other side. It's not a ham frequency. When you're on 146.52, what band are you on?
2 meters.
2 meters. And you can actually use the math to figure that out. You can divide 300 divided by 146, and you get about 2.
Say that again.
Remember we were calculating antenna lengths and stuff? This is where I was saying, if you know that you have 300 divided by 146, you get about 2.05 meters. That would be the 2 meter band. That's your parity check to make sure that you're not losing your mind. If you know that the 2 meter band is 146 megahertz, you can make sure you're doing your math right. Okay, let's see. Why should we never be too close to a band edge? The reason we should never be too close to a band edge, your frequency display could be off by a kilohertz. You could make it so that your modulation doesn't extend beyond the band edge, and you could also say that as your transmitter warms up, it's going to change frequency by a couple of kilohertz. So at one point you were in the middle of the band or right near the edge of the band. And then a few minutes later, because the transmitter is warming up and drifting a little bit, because things get warm and they behave a little differently when they warm up, all of a sudden your signal is now outside of the ham band. And if it's outside the ham band, what can happen?
FCC gets involved.
That's right. And you don't want that. So limitation for emissions on the 219 to 220 band. Notice that it doesn't even show up on this chart. Notice this says that 1.25 meters goes from 222 to 225, right? We actually used to have 220 to 225. There was a proposal which was accepted from UPS where they have these remote package things that operated between 220 and 222. In exchange, we got 219 to 220. But that was already used for something, so we are sharing it with somebody else. So 219 to 220 is a weird thing where we are only allowed to do fixed digital message forwarding systems only. Isn't that a weird specification? Fixed digital message forwarding systems only. So basically like packet bulletin boards and things like that. That's the only thing we're allowed to do between 219 and 220. And that's just like, you know, remember that there's a weird one. That's the weird one.
We need to know that.
If it gets asked.
And also the 60.
Right. And well, but you don't have access to 60 meters, so you don't have to worry about it yet. That's on the general exam. On what HF bands does the technician class operator have phone privileges? If you look, you
15.
will see. If you will see novice technician voice, you have technician phone privileges between 28.3 and 28.5. That would be the 10-meter band.
I was way off.
On which of the following
phone is defined as just voice communication?
Phone is short for telephony, which is any voice. Now, in particular, this is single sideband. You're not allowed to do FM here. On 10 meters, actually, there's a small section of FM, but that's reserved for extra, advanced, and general, as you see way over here on the right.
We wouldn't be there.
Nope. On which HF bands do you have RTTY and data trans? Okay, RTTY is radio teletype. We still do teletype, except we don't actually spit out reams of paper. We have it just pop up on the screen. And data transmissions, notice on this band, we have this red section that says with star. On star, it says novice and technician, CW, RTTY, and data. So between 28 and 28.3, you can do radio teletype and data. So that's on the 10-meter band. You have access to data on the 10-meter band. Which of the following VHF, UHF ranges are limited to CW only? You have these two red sections right here, 50 to 50.1 and 144 to 144.1. That's another one of those weird things that it's actually in the law that we are only allowed to do Morse code.
What's the one for the 1.25?
That's actually not, that's recommended, but it's not in the law.
Okay.
Or if it is, nobody, there aren't enough users up here to worry about it. The 222 band is not very active. So really, these are the ones you need to watch for. 6 meters and 2 meters.
Probably hear you.
6 meters and 2 meters are very active. The maximum peak envelope power. Peak envelope power is the peak power that's being put out that you're allowed when you're on the HF bands. So if you're using your technician privileges on the HF bands, you're allowed to run 200 watts PEP. Now, interestingly, that doesn't sound like a lot compared to the fact that on these bands, you're allowed to run 1,500 watts. But most equipment that you can buy or typically build will be 100 watts or less. So that limit of 200 watts used to be you know, fairly reasonable. And now, actually, that limit is really quite high. I don't even own a piece of equipment that runs 200 watts. Again, up here on VHF and UHF, you can run 1,500 watts. And why is it that, note this says 420 to 430 megahertz, not available along Canadian corridor? That's within, I think, 1 degree of latitude. Why does it say that? And
They have their own laws.
They have their own laws, and they do not operate between 420 and 430, which means that they are not ham bands. Or if they do, they have very limited power. So to keep from interfering with them, if we are in the United States and operating close to the Canadian border, we don't use those frequencies. That's why it says not available. Yep.
Scott, did you send us in the packet a link to this band plant thing that you're
it's actually part of this. It was in the zip file that I sent. This was actually one of the things in the zip file.
Okay, so that was my question. I already have it in the zip file.
Yep, and I actually have I've had my license for now 37 years. I still have this on my wall because there are some times that you say, you know, I don't remember. I better go look. Okay, we're now on to operator licensing. For which license classes can you get a license right now? You can obtain a license for the technician, the general, and the amateur extra. No, I don't know why it's called amateur extra, but that is technically what it's called. Those are the only license classes you can get, although there's also novice and advanced, which are grandfathered and still exist. A license grant is good for 10 years. And you used to, okay, so we're going to go back into the time machine. You used to go and you used to go to the FCC office to take your exam. They would give you a Morse code exam. If you didn't pass the Morse code exam, they would tell you, go home, come back next month. If you did pass the Morse code exam, they would say, congratulations, you passed the Morse code exam. Here's your written exam, which you had no ability to prepare for whatsoever. And they would give it to you, and you'd hand it in, and then a month later, you would find out either you passed or you would never hear from them again. They wouldn't even tell you that you failed. So you basically waited for a month to figure out if you passed or failed. And sometimes it was longer than a month. And then, because if you lived anywhere within 250 miles of an FCC office, you were considered local. That meant that if you lived in Eugene, you had to drive up to Seattle or Portland. If you lived in, let's say, suburban, anywhere in New York, you had to go to the FCC building. It always had to be on a work day. Talk about an inconvenience, right? So now the FCC doesn't do that. They have this thing called the Volunteer Examiner Coordinator, like Kent, where there are 14 volunteer examiner coordinators that administer all the exams on behalf of the FCC. We're a lot friendlier than the FCC grumpy guy used to be. We tell you if you passed. We process the license. Sometimes you can even, if the computer is running, you could even have it up and ready to pay for in 30 minutes or 15 minutes, depending on when it hits. At worst case, you might have to wait for the weekend. As soon as it shows up in the database, which is the FCC ULS database. Chuck?
Okay.
If it shows up in the FCC ULS database, the license is valid if it's listed as active. This is actually also how you say, I want to look and see if a particular call sign that I want to apply for in the vanity program, which is applying for a call sign of your choice, is available. You can see that a license is either expired or canceled or active, or a call sign has never been given out before. The search tools are a little weird, but I'm actually pretty good at it. I've helped maybe a dozen people apply for vanity calls, as well as some clubs and things like that. And So you basically, that same thing that you used, the FCC ULS, that's the same place that you got your FRN, your Federal Registration Number, or FCC registration number. You would search for a call sign being in the database. Once it's in the database, it is valid. If it doesn't show up in the database, it is not valid. You can hold one license grant per person. That's it. So there's also two different parts to a license. One is the operator license and one is a station license. These are two separate things. If it's me, for instance, my call sign is N7JI. I have an operator license and I have a station license that goes with it. If I have a club, for instance, we created a club at TBI, which is N7TBI. That is only a station license. There is no operator license that goes with it. In other words, the operator license carries the privileges. The station license licenses the equipment. For instance, this handheld radio. This is a station. This is an amateur radio station. My station license covers that. If I have a club call sign, there is no operator license that goes with it. It has no privileges. So just anybody who walks in off the street cannot suddenly start operating a club station. The club station has to be operated by somebody who has an operator license that has privileges assigned to it. That station becomes something called the control operator.
So if I go tomorrow and buy a handheld radio, does the license that I get from the FCC cover both the station and the operator?
Because it's you, yes.
Okay.
Now, you could also, for instance, you could go to, you could basically say, okay, well, so you know Andrew Greenberg, obviously.
Yeah.
You could say, Andrew, I just got this radio. Would you try it out for me? Hand him the radio, and he could use his own call sign to use it. He could also, if you're standing there with him, allow you to use his call sign to test it out. Okay. You would, until you have a license, you would be a third party. Third party operation is legal in the United States for anyone who has never had a license revoked.
So,
yeah.
How would that go? Someone with a license, no matter what license it is, tells, I don't know, let's say.
That's how we're going to do it on field day. Basically, if I'm sitting there with somebody who doesn't have a license, we're going to use the club call sign and my privileges as an extra and say, okay, this is what you do.
So you need to have a club license and you need to be an extra for that?
No. I mean, I could use my own call sign and say, I'm going to have you sitting next to me. Here's my license. Here's my call sign. No.
Okay.
But but you still have to operate within whatever privileges are carried by the person in control.
Okay.
The other thing is the person in control has to literally be in control. If somebody starts going off the rails, I have no problem reaching over and smacking the microphone out of their hands and say, this is my license. You can't do that. You're putting my license at risk. This is not a joke. So, what is proof of possession of an FCC issued operator or primary license grant? If it's in the FCC ULS database, it is a valid license. Who can select a vanity call sign? Any licensed amateur. It has to be from the call sign pool that is applied to you with your license class. For instance, I have the call sign N7JI. That is a 1x2. We go by the number of letters. You cannot, as a technician, apply for a 1x2. You could, however, apply for a call sign which is K7ABC. That's a 1x3. Those are available to anyone technician or above. So you have to understand that when you apply for it. I've also had somebody ask, well, why can't I apply for a call sign M7IKE? Why can't they apply for that in the United States?
Different country.
That's a different country. The M is Great Britain. So we want to get to those before they make it to the FCC, because somebody at the FCC, I'm sure, is going and getting a good laugh out of it. Good idea, but doesn't work. So it's important to understand what call signs are assigned to your country.
So it has to start with an N?
No. It has to assign. We have the United States has N, W, or K, or anything AA through AL. Those are the prefixes that are assigned to the United States. So anything that is N, W, K, or AA through AL. Typically, AA through AL are only followed by like a 2x2. So it would be AA3AC. Right? As a technician class operator, you are not allowed to apply for those. So really, you're allowed to apply for anything N, W, or K.
So how do we find out what's available?
You look in the FCC database and you start doing some searching. And that's when you start asking somebody who knows what they're doing, hey, how do I use this how do I use this godforsaken search tool they gave me? Like I said, I'm actually pretty good at it now. So
you lost me on those numbers when you were doing the
all right.
WK, and then you were doing the +2 or whatever you were doing.
Yeah. Here, VK. Mark, what's your call? VK for?
Like Hotel Quebec.
There you go. Okay, so where's the number? So it has 2 letters before and 3 after. That's a 2x3 call.
Yep. The VK's for Australia, 4's for Queensland, the state that I'm in.
Yep.
MHQ's, it's almost a vanity call.
Yeah.
Got my initials in it there. And Q for Queensland.
Yeah, perfect. Okay. If you are in the grace period, let's say you let your license lapse, you have 2 years while it's in the grace period to apply for it again without reapplying for a license. Once it's in the grace period and it's listed as expired, you are not allowed to use it until it shows up as valid again. So you have to reapply.
Do you need to retest?
After 2 years, you need to retest. So don't let it lapse. Which of the following is a requirement of the issuance of a club station license grant? The club has to have 4 members. It also needs a constitution. If the FCC tries to get a hold of you through the mail and they can't, and the mail gets returned back, they can cancel your license. A lot of people use P.O. boxes if they travel a lot, which is absolutely fine, so long as they can get a hold of you, whatever that is. When are you allowed to operate in a foreign country? That's whenever the foreign country authorizes it. In the United States, if we have a United States call, if we go to Europe, the United States is a partner with Europe as far as the CEPT, which is the Council of, which is European Post and Telecom. And basically, we have an agreement that Europeans can come here, print out some paperwork, and operate, and we can go to Europe and print out some paperwork and operate. We can also go to Canada as if we are operating in the United States and vice versa. You can also operate from any vessel or craft located in international waters that is literally American soil. So if it's got an American flag and it's registered in the U.S., it's American soil. Regarding obscene or indecent language, any such language is prohibited. It might be covered by the First Amendment, but the FCC rules say that you're not allowed to. You can get fined for that. What are you allowed to say as far as music goes? Well, we are not music transmitting stations. And so we are not allowed to transmit music unless it's incidental to manned spacecraft communications. This actually came from the days of retransmitting the space shuttle, brought wake-up calls. So they used to retransmit space shuttle audio. It was incidental. It was wake-up music for the astronauts. So that's the only time we're allowed to retransmit music. Now, if we happen to be operating as part of a safety crew or something at a music festival, you know, and we're not making any money doing it, let's say there's a group at the country fair and there's a band in the background, that's incidental. No one's going to care. But we are not a broadcast service. When are we allowed to obscure messages, obscure the meaning of messages? That's only when transmitting controls to space stations or radio control craft so that nobody crashes our spacecraft. Who are we allowed to talk to and not allowed to talk to? Basically, if anyone has gotten with the International Telecommunications Union and said, we don't want those Canadians talking to us in the United States, then they would file a formal request and it would be known that Canadians can't talk to Americans. There are no countries in the world that have actually done that to us at this point. However, a few years ago, there was a group of hams from Italy who went to Yemen and were operating from an island off the coast of Yemen, and they were specifically told that Yemen is technically still at war with Israel, and they are not allowed to contact Israeli stations, even though they were only a few hundred miles apart, because they told the ITU they're not allowed to do that. When are you allowed to make money as a teacher? You're allowed to make money as a teacher if you're using ham radio as part of your curriculum. You can still earn your salary. When can amateur radio operators use their stations to notify other amateurs of the availability of equipment for sale or trade? Okay, so we don't use our radios to sell stuff. We don't go on the air and say, "Hey, I've got I've got a sale on kitchen equipment." No, we don't do that. However, you could say, "Hey, I'm selling a handheld radio. If you know anybody who wants it, it's $200. Get in contact with me." So if it's once in a while, in other words, you're not running a business and it has something to do with radio, then it's okay to use the radio to sell it. What is broadcasting? Broadcasting is information meant for the general public. We don't do broadcasting. However, we can do broadcasting if it's an emergency. There are the words again. Immediate safety of human life or protection of property. The dam is about to break. Even though we're gonna tell everybody the dam is about to break. Run for your lives. That's an acceptable use of broadcasting. Under which of the following circumstances can an amateur radio station make one-way transmissions? One-way is different than broadcasting because it's intended for the amateur radio community. That would be sending out information bulletins. Hey, we got a car accident up on Interstate 5. You might want to look around and find an alternate route. That would be just fine. It's not intended for any one person. You can also transmit code practice. You can also do emergency communications as one-way communications. So what are we allowed to actually say? Communications incidental to the purposes of the amateur radio service and remarks of personal character. Man, my sciatic is acting up. I can't wait to go to the doctor tomorrow. That's okay. And now, when I was a kid, when I was 15 and just licensed and I heard people talking about that on the air, I used to laugh. Now I'm 53 and I don't laugh anymore. Okay, we're almost at the end. Control operator and control types. Who does the FCC presume is in charge of a station? That would be the station licensee. Who must assign a control operator? Let's say I'm the trustee of a club station. The club station would say, "Okay, you, because you have a license, you are the trustee. You are the control operator." So somebody hands me a radio and they say, "You're in charge. I'm now the control operator of this amateur station." Right? It's really actually pretty simple, but there's a lot of words. Essentially, the control operator is the one who's responsible for hitting the button and transmitting. When the control operator is not the station licensee, who is responsible for operation of the station? Let's say that when my friend handed me this equipment, I keyed it up, and it was putting out noise all over a whole bunch of different bands and interfering with people. Who's responsible? The other guy's responsible for giving me a piece of crappy equipment, and I'm responsible for being stupid enough to use it without checking it first. So you're both responsible. Who is accountable if a repeater inadvertently retransmits somebody violating the rules? So somebody gets on your repeater and starts jamming people and cursing. That would be the person who made those initial transmissions, not the repeater owner, because the repeater owner the repeater is an automatic station. It just retransmits whatever it hears. So When can a technician class operator operate in the extra class band? So on field day, you hear a whole bunch of people calling down at 14.153. You look here and you see that that is an exclusively extra class thing. So I'm a technician class operator. It's field day. There's an extra class operator way over there at field day. Am I allowed to take the station and put it on that extra class band? I am not. Because that person, even though he's around, is not under, is not directly in control. I'm the control operator. If I have a technician class license, I can only operate as a technician.
But you're allowed to listen on this.
Oh yeah, you can listen anywhere. But remember, all this is about transmitting. All this is about putting out a signal. So who can be the control operator of a station communicating through an amateur satellite or space station? Basically, if you're allowed to legally put a signal up on the uplink, wherever that is, then it's legal. Even if it gets moved somewhere else or repeated on another frequency that you have no privileges on, you didn't put it there. You did your part legally.
And by uplink, you mean transmitting?
Going up to the satellite.
Okay.
What is an amateur station control point? That's the location at which the control operator function is performed. Automatic control, an example is repeater operation. Remote control is operating a station over the internet, quite literally. There's a lot of people who do that now. They live in areas where they don't have antennas outside. They can operate over the internet. And remote control operation, the operator has to be at the control point. There always has to be a control operator, and the control operator indirectly manipulates the controls. And here we go. This is the very, 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 very last section. More about the FCC rules. When can a station operate without a control operator? There always has to be one. So the answer is never. Who does the FCC presume to be? Oh, wait, I just went to the wrong thing. Okay. Well, that's actually important. You can never operate without a control operator. Okay, when is an amateur station required to transmit its call sign? Every 10 minutes and at the end. Believe it or not, you don't have to do it at the beginning. Every 10 minutes and at the end.
I got that question wrong.
Yep. Every 10 minutes and at the end. So if somebody calls, I don't have to give my call. Now, everybody loves using their call sign, right? So that's usually not a problem, but it's every 10 minutes and at the end, whatever the end is. What's an acceptable language for use to use on the air?
English.
English for identification. When can an amateur station transmit without on-the-air identification? There's only one time. If you're using a remote control craft, you have a handheld Futaba transmitter. On the ham band, you have to have your name, call sign, and address engraved on the transmitter to identify it.
Now explain that on what?
If you're doing remote control craft, let's say you have an RC aircraft, a little RC plane or a drone or something like that, you don't send out an identifier on the signal that's controlling it. The controller itself is engraved with your call sign and name and address.
Okay.
On the aircraft?
The aircraft is just a receiver, unless it's transmitting data. If it's transmitting data, then it has to be identifying as well.
That would be like a drone?
Yeah, or a drone or an RC plane, RC boat.
So where is the engraving?
On the transmitter. You basically can do like an engraved plate and glue it to the transmitter.
Okay.
Does it have to actually be engraved, or can it be a sticker?
I think that used to be the rules. It just has to be some identification. So yeah, it could be a sticker, I think. What's a way to identify a station for transmitting phone signals? You can actually say the call sign out loud, N7JI, or you can have Morse code in the background identifying it. Most repeaters use Morse code because it doesn't interfere with somebody talking. Phonetic alphabet, we use that. It's encouraged, especially for when conditions are lousy or when you need to learn exactly how to spell something. If you're using a tactical identifier like Race Headquarters or Aid Station 6, you can identify as Aid Station 6. Is that a legal identification for an amateur station, yes or no?
No.
Nope. How would you identify your station legally?
With your call sign.
Give your call sign every how many minutes?
Every 10.
10 minutes and at the end. 10 minutes and at the end. So that's the same rule. 10 minutes and at the end.
So wait a minute. So is your call sign and the station's call sign different?
Well, I mean, what I'm saying is if the station call sign is, let's say we're using our club call sign.
Okay.
That's the call sign we're using. And if I'm in control, I'm the control operator of that station's call.
Okay.
That's the call sign.
So you have to give your call sign and the station?
No.
No? Okay.
Well, that's an interesting question. It depends. Let's say that the call sign that we're using is W7PXL. That's the Valley Radio Club. Let's say that somebody who is the trustee of that license is a technician class operator. And I happen to be the control operator that day, and I am an extra, and we are using that station in an extra class band. Somebody could look and say, well, that W7PXL, that trustee is a technician class operator, and what? It's in the extra class band. I would actually have to identify the station as W7PXL/ N7JI, indicating that I was the control operator on that day. That is what we call a pain in the butt. And so what we do usually is that the control operator the trustee of most club stations is usually an extra class operator, because then it's assumed that that station could actually be where it is. So you don't have to do any additional identification. That's why most trustees are extra class operators.
What if you're a technician broadcasting, the one that's like you said, where it's reversed?
Say that again?
In other words, if it's the way it was before, since you were extra, you could broadcast by stating both the call signs.
Okay, wait. We want to get you away from saying broadcast because we never broadcast.
Oh, transmit.
Right, there we go.
So the station's under the control of a technician, but you're an extra.
Right.
So you transmitted both call signs.
Yep.
Now, if the station was under the control of an extra and you're a technician,
that's fine.
You can still broadcast, or you can still transmit.
Yeah.
Okay.
Yeah. I mean, basically, it depends who it's under the control of, and what. And
it wouldn't be necessary for the tech though to put to append his license call sign.
Okay,
at
so
the end
Jill,
of the club call sign.
Jill, let's answer your question. Okay, so go ahead, ask your question, because this actually really applies. Let's see, what call signs could you apply for?
So I was thinking about a call sign that was like NJILL for Jill, or NJ1LL.
Okay. Every call sign in the United States has exactly one number in it. Right? So every call sign has a single number.
Yeah, so if I did NJ1LL.
Okay. What is that? What is the format of that call sign? That is a 2 by 2. All right. So a 2 by 2 call sign is applicable for advanced or extra class.
Okay, so it's got to be 1 by 3.
It has to be 1 by 3 or 2 by 3. So,
okay, so I could go NJ1LLZ or something.
Yeah, right. Or you could do N7JIL if it's not taken. That would be a 1 by 3.
Okay, let me see if that's taken.
But to start with in November, can you still be a technician?
Yeah. The format is just 1 by 3. Any 1 by 3 or 2 by 3.
N1JLL.
Yeah. You could also, yeah, exactly. Or you could do K1JLL or W1JLL. Okay, let's see.
Quick question.
Yeah.
Yeah, I could get that one.
If you go for extra or one of the other ones and you're upgrading, does that mean you change your call sign?
You don't have to.
Okay.
That's something that it's a check mark on the exam or on the form. Which of the following self-assigned indicators is applicable? when applying when using a phone transmission. So self-identified indicators would be like N7JI. What comes after it, you can pretty much add anything. So I could say /QRP, which is low power. I could also say N7JI/W6, which is in the United States and California. If I was in another country, I would be, for instance, CE5/N7JI. That indicates that I'm operating in the Biobío region of Chile, which is how I had to identify myself. So basically, if that prefix comes before the call sign, that means that you're operating as a different call sign. So the / indicates that you're something else, right? / before or after. If it's a self-identified identifier, then this is either spoken as / or slant or stroke. Those are 3 words, 3 S words that apply for a / mark. Okay, third-party communications. Third party. So let's say that station A, we're almost done. Station A and station B are having a nice conversation. And station A, let's say they have a 3-year-old kid, and station B also has a 3-year-old kid. I could let, if I'm station A and my friend is station B, we could each let those 3-year-old kids use our equipment and have a nice little conversation. We actually do this at the Eugene Science Center. That's how we get kids on the air. They are then, this station is a third party, and this station is a third party. They are engaging in third-party communications. Third-party communications are permissible when the countries in which both stations allow it. If this is US to US, that's perfectly fine. It works great. If one of them's Canada, that's also fine. If one of them is Japan, that is not fine, because the United States does not have a third-party agreement with Japan. The list of stations with which we have a third-party agreement, which we have third-party agreements, is actually on the FCC and ARRL websites. And the reason that's true is because in a lot of countries, the telecommunications organization is a part of the government. In a lot of countries, that agency also ran the phone company. So why would the phone company intentionally take money away from it making long distance fees just so people could make ham radio calls? So they said, okay, we're not going to allow that. That was true of Great Britain, of Germany, of a lot of European countries where the government ran the telecom company. And in a lot of places, that rule still holds true. And finally, if the FCC knocks on your door and wants to inspect your equipment, you have to let them in. So, Mark, WIA, right? Is WIA the ARRL equivalent, or is that the Wireless Institute of Australia, which is part of the government?
No, it's not a government agency. It is independent.
Okay.
There is a bit of contention, though. We've got a new one called RASA, the Radio Amateur Society of Australia.
Okay.
And they're kind of at war with each other.
So who is the Australian telecom agency?
ACMA.
ACMA.
Australian
okay.
Communications Management Authority, I think it is.
Okay. And they're the ones who actually assign the licenses, right?
They're the ones, they actually, there's a third-party agreement now with a university in the state of Tasmania, the little island state down the bottom of Australia. And that university has a department which does allow effectively the equivalent of the VECs. They manage our VECs,
okay.
And they mark the tests, and then they send the approvals to the ACMA, who give us the license.
Okay.
For selecting your own call sign, is that a default action, or do you have to apply for a specific call sign?
All right, so that's a totally separate thing. So here, I promised that I would show you guys. So what we're going to do is share my screen, and we're going to go to FCC ULS search, advanced. Here we go. Search amateur. Amateur license FCC search. And so here you go. This is where you search for licenses. And, you know, I'm going to go N7JI, and let's see if it's been assigned, what the history looks like on
Just
it.
apply for it for us. Show us how to apply.
Well, oh, and this, oh, look at that. Okay, now, notice this says that it was canceled 4/24/2022. You couldn't get this for another 2 years.
Yeah, and I wouldn't want to do that to that guy.
Well, you could. I mean, but
Yeah.
you can't, legally you can't. It has to be vacated for 2 years before you can apply for it. Because they could always re-up. You know, it's basically in the grace period right now. So, okay,
I think there's a rule where you can actually, if it's say your grandfather's call sign,
right.
you could apply for it with their permission.
If
or
it was
with
a
the
family
family's
member, a deceased family member, or even a living family member who doesn't want it back, you can apply for it within the 2-year period. So let's say that I want to look for any JLL calls that start with N, because you don't actually have, it doesn't actually have to be in that call number area. The United States has 0 through 9. And you could apply for, you used to have to do it geographically. You don't have to anymore. So an underscore is the wild card. And we can, let's say, bring up 100 of them, see who comes up. This might take a little bit. Yeah, there's only 9. Okay. And you could, it looks like the 8 was applied. You notice there's 2 N4 JLLs. One of them, this Frederick Stegman, it expired in 2017. And then this Joseph L. Lyons, JLL, applied for it, and its expiration is 2030. So that's an active license. So you have to look for multiple entries of the same one. But for instance, there N0 JLL has never been applied for. And N7 and 8, those are both available and have been for a very long time. So this is how you do a search for licenses that are or are not available anymore. So like, now as far as actually applying for it, there's if you'll already have your FRN selected, right? You need the FRN to take an exam in the first place. So then once you've done that, you have to, if you do a search for apply for FCC vanity call sign. Amateur call, vanity call sign, applying for a vanity call. So here's the ARRL page. Here's instructions for doing so. So there are lots of step-by-step applications for doing it.
But if we just take the exam, they assign that's a call sign?
When you take an exam, you get assigned a sequential call sign. You don't have any choice. Might turn out you might like it. So.
Okay. And after the exam, do we need to do anything? Because I know we need to pay the $35, but what's the process for that?
Okay, so if you pass the exam, the data gets submitted to the FCC. The FCC then says, okay, here's a license, I assume, waiting to get created. And it'll email you as something that says, or you know that it should be there. And you can go and, like I said, I've never done this because I've never had to pay the $35 because that was implemented in April of this year. So I don't know exactly how it works, but it is working for people because I hear new hams on the air all the time around here.
Still a lot cheaper than Australia. I'm paying $50 a year for mine.
Yeah, and this is $35 once every 10 years. So, all right. Well, we're done with this whole thing. Do we have any other questions? There's got to be questions.
The time that I had blocked out tomorrow for this class is the time that potentially the exam was going to be given. Is that why I think we're coming back again tomorrow? I'm just wrong.
Well, I mean, are you signed up to take a test?
I did, but I had already signed up and it's going to be on Saturday, not tomorrow.
Okay, that's fine. So, I mean, one thing I can do is if anyone wants to show up tomorrow, I can be here at the same time. You can, like, you know, if you have any questions, you can come and ask questions. Which is kind of the other reason that, you know, kind of in the background, I thought, you know, let's see, the exam is tomorrow afternoon because that's when they were available. I'll make myself available. So I'll be back at 9 tomorrow morning.
Okay.
If you
So
have
you
any
can
questions.
take the test on Saturday?
You can take it 6 days a week through this group.
Wow.
Yeah, they give exams twice a day, Monday through Saturday.
So if I don't feel good about taking it tomorrow, I can take it on Saturday?
If you really want to.
Cool. Yeah, I feel like I need to study more.
Well, practice exams. If you're averaging in the 80s, you know, mid 80s and higher, you're gonna pass.
Well, I'm trying to get through the material so I know what they're talking about. Because I didn't do too good on the practice exams because I didn't even know what the stuff meant.
Yeah. Well, now let me ask a question. Do you feel like you know more than you did?
Yes.
Oh, good. Okay. I'm going to stop recording now.